All right. So tell me now, what you guys want to do? On the screen, I just this, as you can see on the screen, this is the pure maths. Hold on, this is the pure maths paper that I just did today. I was basically working on some of the questions. I tell you some of the questions were like, I mean, not normal. I mean, they're good enough, but I don't think they're friendly for exam. So it's basically working them out. So I just read from it for the total 12 questions. I'll work them out later. All right, so that is it. So I'll come back onto this later. So it's for you to tell me what you want to do. What you want to do.
You can go over stationary points.
All right, so it's a lot easier if you just find a question and explain from the question, because I might go trying to teach it from scratch. I would just use up a good bit of time. Right? But if you find a question while doing the question, that's where we're at now, tomorrow's exam. While going through the question, I will explain. You get me? Why I do what I do. So look at the past papers I have. Find a question. Stationary points is usually around 4 or 5 or so. 4, 5, 6, somewhere around there. So let's look at the past papers that you have quickly. And I told you guys to do that, come with the question that you want me to do. That is where we're at. Can't teach anything from scratch now. While I'm doing the question, I will explain what is happening, because nothing is new to you guys now. Nothing is new. So let's do that for me now, please. You have any question readily available?
Yeah, that's right.
You have any question readily available? Corona?
Can I ask you a question then? Can you give my question? The 2017 question 4.
Hold on. Add maths people too. All right. Number 4 on this paper. Carry on, I look for the question you want me to do. That's a process. I can't teach anything from scratch now. Tomorrow's the exam. Yeah. Number 4. All right, this one. All of it?
Yes, sir. Yes, sir.
All right. This is circular measures. A circular measures question. Hold on a second. All right. This question said the figure shows a plot of land, ABC, not draw the scale. Section ABC, ABCD. ABC is used for building, and then the remainder is used for farming. So I'm going to put a B on this. Remember that is of building, and here is of farming. All right, that's a sector of a circle, and that's a triangle. All right, so it's really a circular measures question. So the radius BC is 10. So this is 10. So because this is a sector, this also is going to be 10. That's the hypotenuse on that triangle right now. So if you want, you can put it on there. So I always go to populate the diagram. So I'm going to put 10 meters on here from now. All right. And it says the angle BCD is a right angle, right? Here is a right angle, right? Angle. Oh, here is a right angle. And they give us this angle theta. All right. It says if the building space is 50 pi over 3 meters squared. That's inside here. So they basically tell that the area of that sector is this. Calculate the angle in radians. That's this angle. So we need to use a formula for the area of a sector when the angle is in radians. And that formula is half r squared theta. That is the area. They tell you that it is equal to this, 50 pi over 3. And you're trying to find the theta because the radius is 10, the r is 10. So since the r is equal to 10 in this formula, this is really half of 100. So this is really 50. So that is 50 theta equals 50 pi by 3, not 5, 50. This is really 50 theta. So the 50 is cancelled and the theta therefore is pi by 3. Theta is pi by 3. And pi by 3 really is equivalent to 60 degrees. If you don't know this, just put 180 for the pi. All right? So that we're really working with 60 degrees. All right, the next part says, working in radians, calculate the area of the farming, used for farming. So I don't want the area used for here. Now, if this angle is 60 degrees, it is pi by 3, 60 degrees. Then this angle right here, first you can use this angle right here. If this is 90 and this is 90, you could use that angle in. So this angle is also theta up here, but still, you can just come down here and say that this angle inside here, so now, is actually 30 degrees or pi by 6. If you're working in degrees, thinking in degrees, you would know, because if here is 60 degrees, then here is 30 degrees. But if you don't know and you're working in radians, then this it would be pi by 2 minus the pi by 3 that we got up here, because this is pi by 3. And it would work out to be pi by 6. You get me? But when you know the angles in degrees, it's a lot easier, quicker, because you got this angle to be pi by 3, which is the same as 60 degrees. So this angle here is 30 degrees, which is the same as pi by 6. So you're working in this angle. And what the question asks if I know the area? No, we're working in this red in this triangle that I'm going to mark out in red for farming. I want to find the area of it. I know the hypotenuse is 10. So to find the area of it, we can find this side and use half AB sine C, or we can find this side as well and use half base times height. So if you use cos, this side on here, if you use cos 30 equal adjacent over hypotenuse, then this side is going to be 10 cos of the angle pi by 6. 10 cos pi by, make it smaller. Right, so this side is going to be 10 cos pi by 6. That's what this side is going to be. And the height up here, if you use sine equal opposite over hypotenuse, sine equal opposite, sine of the 30 degrees equal the opposite side over the hypotenuse equal, then the opposite side that you want, you multiply the hypotenuse over here. And so it is going to become 10 sine pi by 6. Then the area becomes half the base times the height. So I'm just going to use these two figures and calculate area like this down here. So area is for farming, is the area of that red triangle. So the area for farming becomes half the base, which is 10 cos pi by 6 times the height, which is 10 sine pi by 6. If you want, you can drop all that in the calculator, but you can go and say the 10 times 10 is 100. Half of the 100 is 50. So this is 50. The cos of pi by 6, which is cos of 30 degrees, is root 3 over 2 times the sine of pi by 6, which is sine of 30 degrees, which is a half. So a lot easier when you know these things. You don't have to jump to the calculator. So this becomes 25 over 2 root 3, because 2 into this goes 25. over 2 root 3. So the answer becomes 25 over 2 root 3. What is the measurement? The measurement is in meters squared. That is it. This part down here now, it says, given that, there are these things you should know in your head, but I'm giving them to you. I want you to, without using a calculator, show that this equals that. All right? Watch this now. First, you have to realize that that's a compound angle. And this is a double angle. That's what it is. So see it, you know, the left-hand side, use the pen a little darker. The left-hand side, which is this side, the left-hand side becomes equal to what's expansion of cos? Cos, sine. It's going to be on the formula sheet. Let me see if it's on this sheet. If you don't know, then you're going to have to depend on the formula sheet. So you'd have to use this one. Right? So if you look at it, expansion of cos with a plus. There's a plus that is there, I think. We have a plus here, you have a minus here, but it is cos, sine. Cos, sine, and the A follow the B the same way. You can just know these things in the head rather than have to depend on formula sheet. But if at this point you don't know, then you just have to go and work it, right? Gone too far. You just have to go and work. So coming back here now, so I'm going to expand this with a compound angle for cos, which is cos pi by 4. Since it's a minus, I'm going to get a plus. Well, first, cos pi by 4, cos pi by 3. That's my cos. Since it's a minus, I'm going to get a plus in between them. Plus sine, which is sine pi by 4, sine pi by 3. That's the numerator. Right. Then we have to realize that this expression over here, let me show you what it is really. This expression under here is the same as the sine of 2 times pi by 3. So using the double angle formula now. It's not on the formula sheet, you know, so you have to figure it out from the compound angle. But if you know it better, what's the double angle for sine? See here, sine of 2a equals 2 sine a cos a. In this case, the a is pi by 3. So the denominator here in this expression, this denominator, it becomes 2 sine of the a, which is a pi by 3, then the cos of the a, which is still pi by 3. Okay, recognize this 2 pi by 3 as 2 times pi by 3. So they have a double angle, and the a is pi by 3. And you're putting in the values now. Now, if you don't know, you have to be looking here, so looking here, for those values. When you can just know them, it's better when you just know them in your head. So this equals now, the cos of pi by 4 is root 2 over 2. I don't need no calculator, root 2 over 2. The cos of pi by 3 is 60 degrees is a half. Plus, the sine of pi by 4 is root 2 over 2. The sine of 30 degrees, the sine of 60 degrees, this is 60 degrees. The sine of 60 degrees is root 3 over 2, root 3 over 2. These multiplying over this here. So now, let me shift this down. This now, this one, you're going to get 2. The sine of pi by 3, the sine of 60 degrees is root 3 over 2. Times the cos of pi by 3, that's the cos of 60 degrees is a half. Now I want to get this fraction term of the denominator. So let me have here, so I want to get this. It's going to give me 4. It's going to give me a 4. It's going to give me a 4 on the denominator of each of the terms. They're gonna all cancel out themselves. Or if you want, you can multiply numerator by 4 and multiply denominator by 4. So this 4 cancels these. And this 4 cancels these. Alright? But you could also say that cancel each other. Alright? So that is it. So I'm gonna be left with equal root 2, because the 2 times 1 is gone, you know, that is root 2. It's going to become root 6, because root 2 times root 3 is root 6. Again, the 2's on the here, so gone with the 4. So it's plus root 6. On the denominator, these 2, them gone. All I'm left with is 2 root 3. 2 root 3. And that is equal to the right hand side of the proof. That's it. So far so good? So far so good, guys?
Yes, sir.
Yes, sir.
Alright. The next part now wants us to do this proof. I'm going to show you this again today. Alright, last time I told you this now, because tomorrow's the exam. You see, every time you say 1 plus sine or 1 plus cos, or even say 1 minus sine, I say 1 plus sine, I say 1 minus cos, I say 1 plus cos. You must remember this what I'm going to write on the screen now. They are factors of the squares of sine squared and cos squared. That's what they are, factors. Let me show them over here so to you in red. So you're looking to use them. And you're looking for them coming into play. So let's do for cos squared first. So cos squared theta initially is 1 minus cos, 1 minus sine squared theta. What is 1 minus sine squared theta? It's the difference of 2 squares. It is equal to 1 minus sine theta times 1 plus sine theta. Let me shift this over somewhat. So let me shift it over. So that one is that. So anytime I say 1 minus sine or 1 plus sine, I'm thinking of this, thinking of that. Because they are factors of that. And the other one is cos, is the sine squared. So the sine squared one is that sine squared theta is actually equal to 1 minus cos squared theta. And there's a difference of 2 squares. It is 1 minus cos theta times 1 plus cos theta. Again, let me shift this over a bit. That's what it is equal to. So anytime I'm doing a proof and I say this and this, I know that if I multiply them, I'm going to get that. So I'm always looking to do that. Or if I have this, I can factorize it into these two. I'm looking to do it. So remember that these relate to this and these relate to that. All right. Let me write the question now, though. Now, what I'm seeing here is that they give you these two expressions and they turn into one. I'm looking at this. I remember I said this. I remember I was told you that this is a factor of this, you know. I just told you. See it here, so this is a factor of this. And then I'm to have that up here. So what am I gonna do? I'm gonna factorize this into this. But if you want, you might have to write it firstly as that. But if you know, say it already equal that. Bonus. So you just write it. You get me? That's why I tell you the more things you know, the better. So the left-hand side of this equation is going to become this 1. I'm not going to change it yet. 1 minus the numerator is this, which factorizes into these. So I'm going to just write these for the numerator. So I'm going to write the numerator as 1 minus sine theta bracket 1 plus sine theta over 1 plus sine theta. And then these cancel each other and it's done. 1 plus sine cancels 1 plus sine. So all I'm left with now is this equal 1 minus this bracketed term 1 minus sine theta. I'm open up the bracket to 1 minus the 1 that gone. And then the minus sine becomes sine theta, which is the right hand side, which was a lot easier when you can make those connections. Question done, right? Question done. All right. Good with that?
Yes, sir.
Good with that?
Yes,
All right.
sir.
OS.
Sir, you can do number 4A and 3A pan 2023.
2023?
Yes.
2023. Sir. All right, 2023. So I sent the video. I did this video for you guys the other night. You saw it? You saw it?
No, sir, I did.
I put it in the group. No, I follow the group, man. I did it for you the other night. I worked out this paper, 2023, because I know that I didn't give it the solution. I worked it out and I sent videos in the group. I sent the link to the video in the group to all of this paper. I worked it out, stay up late one night and I worked it out. I recorded it because I know I had a limited opportunity maybe to do it with you. So I did it. It's in the group. The link is in the group. This week, same with, I think I did 2 nights ago or 3 nights ago. What number you want? Number what?
3A and 4A.
3A. 3A. All right. So this one once the coordinates of the center of a circle, and then I want the radius. All right. I explain all this in the video, but no problem. So what I would generally do is write this out of this form and write it into what we call a standard form. So the standard form is like this. A is like this, x minus a all squared plus y minus b all squared is equal to the radius squared. This equation can be transposed into look like that. When you get it to look like that, the center of the circle has these values as its coordinates. Note it is x minus a and y minus b. The center point will become the point AB. These have to be minuses. Very important. And the radius is this value. When you get r squared on the right side, the radius is just r. That's what r stands for. Now, that's not the only way to do it, to find the center point, but that's the method I prefer to use. There's actually a formula way to calculate the radius and the center. But I don't tend to use it. I'm going to convert this into that formula by computing the square. So I'm going to compute the square of the x values first, put them together. So I'm going to write x squared minus 8x. I'm going to put the y squared with the minus 18y plus y squared minus 18y. And I'm going to add back this 93 and put it equals 0. You're going to compute the square of these two terms, x terms, and compute the square of these two terms, the y terms. How do you compute the square of these two terms? This is already just x squared. It simply becomes bracket x. Half of this value goes in here inside the bracket. Half of it. That's minus 4 squared. Then you have to subtract the square of this value, which is 16. I'm going to just put 4 squared this time. Remember what I did. I put half of this value inside here. Then I subtract the square of that value. Now, whether it's positive or negative, you have to subtract the square of the value. So you subtract the square of that value, the square, and subtract the square. I'm going to do the same thing to this pair now. All right, let me shift this. All right, let's do it here. So I'm going to look for the y now. Do the same thing with this. So I'm going to get plus. From this, I'm going to get y. Half of this going in the bracket now, which is negative 9 squared. I have to subtract the square of this now. Square of that is 81. And I'll put back this plus 93 equals 0. What did I do? Complete the square. I put half of this here. And then subtract the square of that here. Then I just need to consolidate the values now. That's what the center is. So I'm going to get the equation form x minus 4 squared y minus 9 squared y minus 9 squared. And I'm going to work out the values and put that over this side as an r squared term. Let's look at the values now. I shall put 9 squared here, so instead of 81, 9 squared. So in terms of the values, I have negative 16 from this, negative 81 from this, and we have plus 93 right here. So what do I get from those? This and this give me negative 97 plus 93. And so I'm going to get negative 4 on this side of the equation. The numbers work out to negative 4. The negative 4 is going to go on the other side and become a positive 4. That positive 4 is 2 squared. So I'm going to get 2 squared on the right side. Instead of the 4, when negative 4 goes over here, it becomes a positive 4. I'm going to go write it as 2 squared. Why did I write it as 2 squared? Because I'm trying to write the equation in the standard form to match this up here. All right. Now that I have that, I can write what my center is. Right? See it here. It means that the center, see, is x minus 4. So this is my A. This is my A. Y minus B. This is my B. Equals r squared. This 2 is my r, my radius. So the center point has coordinates 4, 9 is the center. And then ask for the radius. Radius is just 2. Radius is just 2. So the radius r is equal to 2 units. It's a length, 2 units long. And I like to ask questions like this down here. I ask for the center, for the tangent, or I ask for the normal. They always do that. Once I give you a circle question, they tend to do that all the time. All right, so they want the normal this time, just the normal. They don't want the tangent. So you draw, I normally make a sketch. So make a sketch, and the center point is this, 4, 9, right here. That is 4, 9. Now where would 2, 8 be? 2 is to the left, and the 8 is below. So therefore, I can put a point down here, for example. Let me shift over the 4, 9 then. I'll shift the 4, 9 up. Put the 4, 9 up here. So, right. So this point would be maybe somewhere around here. I like to kind of put it where it would more than likely be. So that point is the point 2, 8. And so, trying to find the equation of this normal here. Try it in red. This normal. That is a normal. Put an N on it for normal. I'm trying to find the equation of that line. You should have a problem because you have 2 points that it passed through. So you need a gradient and you need a point. We can look at the values and know the gradient. From here to here, you have to rise 1. From 8 to 9, you rise 1. And from 2 to 4, you run 2. So the gradient is a half. We could calculate it still. The gradient of the normal is the difference in y over the difference in x. This y value minus this y value. That's 9 minus 8 over this x value minus this x value. Always use the point to the right side minus the point to the left side when you have the diagram, all right? Good practice. So I'm doing the 4 minus 2. This becomes a half. That's great of the normal, a half. Then you can use any one of these 2 points to find the equation, to get the equation, because they're both on the line. Let's say I'm going to use this point. Let's call this point P. This one. Then the equation of that normal is going to be y minus the y value of P equal to the greater of the normal into x minus the x value of P. So it's y minus the y value of the P is 8. So it's y minus 8 equal to normal is a half. A half into x minus the x value at the point is 2 right there. 2. Then we're going to expand. So the y becomes equal to, I'm going to transpose this negative 8 and make it positive. So the y becomes equal to half x. Then half of this negative 2 is negative 1. So we have negative 1 over there. And then this 8 come over and give me a plus 8. Plus 8. So they give me 7. So I'm going to put a plus 7 there. All right. And basically that is it. Now I'm just going to work if that asks for the tangent. Let's just work if that asks for the tangent, right? So if that asks for the tangent, which is now with this line, I'm going to draw it in purple. Going this way. That will be a tangent. Right? You would still have to find the gradient of the normal right here. So first, because it is the normal alone that passes through 2 points on the diagram there. The tangent only pass through 1 point, but the beauty is that the tangent and the normal perpendicular. So if you know the gradient of a normal, you can find the gradient of a tangent. So I'm going to just make this a little bit smaller and I'll show that just in case. Because I ask for tangent more times than I ask for normal, you know. So we'll do that part in purple. So first, say the gradient of the tangent would be minus 1 over the gradient of the normal. So to get that, like we take the half and put it under here, so where the normal is. Or the short way to do it is to take this, flip it, and change the sign. So I flip it, it becomes 2 over 1 first, and I change the sign to a minus. And so it becomes negative 2. All right? That's the gradient of the norm, the tangent would be. So this will work out to negative 2. And you can use the same point because the tangent passed through that point. So the equation in that case, the tangent equation in that case, would have been y minus same y value at p equals the gradient of a tangent into x minus the x value at p. You plug in the values now. It will be y minus the y value at p is the same 8. 8. The gradient of a tangent would be a negative 2. Negative 2 into x minus x value at p would be a 2 right there. 2. That's what you would have. And so the equation would have been, let's consolidate now. Y equals minus 2x. This minus give me a plus 4. And the minus 8 go over and come on plus 8. Plus 4 and plus 8 is plus 12. That would be the equation of this tangent if they wanted it. And to find the equation of a tangent, remember you have to find the gradient of the normal first. So even the question you just asked with this alone, you would need this normal gradient in order to find the tangent gradient based on this method that we're using. All right. Is having another part? You want to do this at all? That's just 4A you want. Is 4A say? I don't want to do any question or don't. Let everybody write with you know. Which other question I said? Terona. Huh? I don't hear you. 4A. All right. 4A. All right. Yeah, this is a nice question. Unique and nice. So the question gives us this function. And it tells us that this is the gradient. It means that when we differentiate this, it equals that. That's what it means. You know? And it also tells me that my stationary value is this. No, this means that this is the y value at the stationary point. That's what the stationary value is. That's the information they're giving us. Right? All right. So first thing I'm gonna do is differentiate this and compare it to that they say it is. Right? So that's what I'm gonna do. So dy by dx, dy by dx is equal to, differentiating this, you know, equal to 2ax plus b. But they tell us that it is equal to that. So I'm going to write that. it is equal to this thing, 9 minus half x. So these two things equal. It means the constant value here equal a constant value there. And it means that 2a here equals a minus half there. That's what it means, you know. So because it's 2 is the same function. So it means then the b constant equal a constant. So the b equals 9. And the coefficient of the x equals the coefficient of the x. So the 2a equals negative half. The important thing again here is to make sure you put the negative half. Equal negative half, which means that the a equals a quarter. The a equals negative a quarter. So we have two other values already, a and b, right? Now, what you know about a stationary point is that the dy by dx equals 0. So at the stationary point, this equals 0, and it gave us information about the stationary point. Let's deal with that now. So we have two other values already. We need to know where the stationary point is so we can put it back in the function to find out what the a is. So let's go. So I want to say at the stationary point, dy by dx, which happens to be this, 9 minus half x, is actually equal to 0. So we really know working right here. And we also know that at the stationary point, the y value is 5. So this is going to tell us what the x value is. What is the x value? The x value from this has to be over 18, because half of 18 is 9. If you work it out, you're going to get 2 multiplied by 2 by 18 minus x equals 0. So x equals 18. Anyway, take it, the x going to be equal to 18. So the x is equal to 18. And then tell us the stationary value is 5. So the y is equal to 5. I gave you that. This is x value at the stationary point. They got it from this. And they give you this information that the y value is 5. So it means that the curve passes through the point 18, 5. That is your stationary point. It is a point on the curve. So because that point on the curve, you can take it and substitute it in the equation of the curve. That's what it means. You can substitute it into the equation of the curve. I'm trying to find the c now. You're trying to find the c. So that's what we're going to do. So we're going to substitute it into the equation of the curve. So we're going to put the 18.5 into the curve because it's a point on the curve. And we're going to get the x is 18. So x is 18, right? So we're going to put it here. And the a is negative a quarter, right? The a is negative a quarter. So we're going to get negative a quarter times 18 squared, because the a is 18. Then the b is 9. I am multiplying it by this x, this 18 value x here. So we're going to get plus the b is 9 times the 18, which is the x, plus c. That whole expression is equal to a y value of 5. So the y value is 5. This equal 5. And solving this for the x, for the c. So basically work out all of this and treat it with the c. So we can go over here and work it out, and so we get it with the calculator. I can't bother work out this step by step. Hope the noise is not too much for you guys. I'm at work, so these guys don't make a lot of noise. I think I might have to move out of this room. They're really noisy. I was hoping that they would have gone. I left already. So I'm gonna work out this and then transpose it over here. So let's see what they work out. So all right, I'm gonna do 5 minus this one and plus this. Because when I want to go by this going to turn a minus a plus, right? So the c is gonna be equal to 5 minus this, minus 9 times 18, and then I'm gonna add this, which is really 18 squared over 4. So it is really a fraction 18 squared over 4. That is the C. So the C then equals negative 76. So those are your answers. This is one answer. This is one answer. The B. This is one answer. The A. And this is the other answer. The C. All right. Then this one says determine the nature of a stationary point. Now I already know that's a maximum. You know? I want to know is maximum because the A is negative. But I think I want to use the second derivative to do it. Marks. I could maybe say since the A is negative, it's a maximum. But I think maybe the more if we do the second derivative. But this is the first derivative, you know, this. So we have dy by dx equals 9 minus half x. We differentiate again and say d2y by dx squared is going to work out to be negative a half, which is less than 0. Therefore, it's a maximum. Stationary point is a maximum. Therefore, stationary point is a maximum. Get me? What to go do that? I'm going to move from this room in a minute.
Yes, sir.
Okay with that? The noise, you can hear the noise in the background? You guys can hear the noise in the background? I'm using a mic that is supposed to drown out noise. You know? You can hear it, right? Huh? Somebody answer the man, Jesus.
Yes, sir.
Yes,
Yes,
sir.
sir.
All right. Okay, guys, I moved. So I'm in a more quiet place now. All right, good. Let's have some peace. What is the next question y'all want to do? What other question? Corona, you good now? Corona. So you just wanted 8A. Is it 8A or 8A and B? 4A, I mean. All right. All right. So somebody tell me the question you want to do. Seems to the pure maths student never asked me for doing nothing for them last night. You know, like everybody ready. So nobody has any question that they want me to do. So I can go home. Well, I can't hear you. I can hardly hear you. What you say?
I said I'm looking for more questions, so don't leave it.
Okay. They're ready. All right. You have nothing?
Sir, can you work out 5A? Sir, can you work out 5A?
On the same paper?
Yes, sir.
All right. All right. Question says, consider a toy truck moving along a miniature racing course with an acceleration that is this. So we have to know is that when you have acceleration, you integrate it to get velocity, and then integrate velocity to get displacement. If you have displacement, you differentiate displacement to get velocity, and differentiate velocity to get acceleration. So since you have acceleration here, you're gonna have to integrate if you want to get velocity. All right? It says assume that the speed of the toy truck is measured in centimeters per second. So we're working in centimeters, and the time is in seconds clearly. It says outline an equation for the speed of the truck. Outline how an equation for the speed for the truck would be found using the given equation. So this equation for acceleration, I want to find the speed. You have to integrate. Why is that? Because dv by dt, sorry, is equal to acceleration. So if you want to find the velocity, you have to integrate. So the acceleration is going to be the integral of the velocity, which is the velocity is going to be equal to the integral of the acceleration with respect to time. That's how we're going to get this velocity, by integrating the acceleration. So if you want, you can go further without actually working it out and just put this as being equal to the integral of this whole expression, which is 9t squared plus 2t minus 1. And don't forget to put your dt at the end. You must integrate with respect to something at all times. All right, minus 1 dt. It's all 1 marks. I don't think they wanted to work it out. They just outline how. This is my premise. I can tell them that the v is the speed. V is the speed or velocity. Velocity. All right, tell them that the v is velocity. Yes, to find the speed on the track. Now, the problem I have discussed is that they don't give you any fixed condition or starting condition. Like I say, they don't start from rest. So you're gonna have to assume that when t equals 0, the speed is 0. Right? Like the toy truck is initially at rest. That's how I know. So you're gonna assume, because they don't give us any. And normally a question like this, they will give you. Because so once you're integrating, you're gonna have a constant of integration, you know? And they normally have to tell you something. Like when t equals 2, the v equals 5. Something like that. Or they might tell that it starts at rest. So if it starts at rest, you know, so when t equals 0, the velocity is 0 at the start. But they don't tell you anything in this one. So I'm going to assume, say, start from rest. All right, because they have not said anything in this one. But to find the velocity, we need to complete this acceleration and then plug in the 10 in it. All right, so the velocity formula is going to work out. I'm integrating this now. Add 1 to this point divided by a new point. It's going to become 9 over 3. So 9 over 3 is same as 3. So I'm going to get 3t cubed. When I integrate this, then this one going to become t squared. I'm going to add 1 to power get 2 and divide by the 2. So I'm going to get t squared. So I'm going to get plus t squared. Then when you integrate the 1, you're going to get t. Let's put in the plus c still as a constant of integration, since we did not do it in the limit. And just tell the examiner that it is 0. So we're going to say, we're going to assume, because they didn't tell us anything, that when t equals 0, the velocity equals 0. So therefore, the c equals 0. The constant is 0. But you have to show that you consider a constant. And the one when the velocity is 10. The one when the time, is 10. So when the t equals 10, and this is actually 0, remember that is 0, right? The velocity becomes 3 times 10 cubed plus 10 squared minus 10, and this is plus 0, so I'm not going to add anything. And they wrote that out. So this is 1,000. No, that is 3,000. This is 3,000, because that's 1,000 times 3, that's 3,000. That's 100, that's 3,100, 3,100. That's minus 10. So you take 10 off of the 100, you get 90. So it's 3090. 3090. You have to say centimeters per second. Because the acceleration is centimeters per second squared. Then this one now says, find the distance covered. Find the distance covered between 10 and 5 seconds. Express your answer to the nearest whole number. So to do that, let me show you. It's like you have the curve, right? It's like you have the velocity curve, right? And this velocity curve for this one is going to be a cubic. Remember, this is 0, so you're going to pass through the origin. So I think it will go maybe something like so. Something like so. And I think what's going to happen is like, that's a velocity time graph. But over here, not really valid, because that's negative. So it's like, we're right here. And this part is not valid. But you don't need a sketch, I'm going to show you something. And you want to find the distance traveled between 5 and 10. So it'd be like you want to graph between 5 and 10. Because distance traveled on a velocity time, graph is area under the graph. So you're integrating the velocity graph between 5 and 10 to get the distance traveled in that interval. And so we're going to write it here. The distance traveled, which is S, becomes the integral between 5 and 10 of the velocity with respect to time. And this is the velocity, this. Without the c is 0. So we're going to integrate that. So integrating between 5 and 10 of that velocity function, which is 3t cubed plus t squared minus t dt. So integrating that is, they don't give a lot of space for these things, you know. I tell you guys, they don't give a lot of space, so you know you have to know your stuff and be efficient with your work. Don't give a lot of space for it to be writing stuff to figure out. Just drop it. So really and truly, you know, you should really start this right here. So you're supposed to already know this. That's what this means, you know. So this becomes equal to, add 1 to the power divided by the new power, we get 3t to the 4th power over 4 plus, add 1 to the power divided by the new power, we get t cubed over 3. Add 1 to the power divided by the new power, we get minus t squared over 2. And we're working that out between 10 and 5. And you plug in the values. So you're going to plug in the 10 first. So I plug in the 10, I'm going to get 3 times 10 to the 4th power over 4 plus 10 cubed over 3 minus 10 squared over 2 in the first bracket, minus, put in a 5 now. So I'm going to get 3 times 5 to the 4 power over 4 plus, and this is in the bracket, right? Then I'm going to get 5 cubed over 3. I'm going to get minus 5 squared over 2. And then you put all that in the calculator and work it out. So let's see what you get. Just type it in the calculator now. So I try to work out all of this step by step. Just put it in the calculator exactly as it is there. You get the answer. So the first one is a bracket fraction 3 times 10 to the power 4 over 4. Come beside that and put a plus. That becomes 1,000 over 3. 10 cubed is 1,000. So I'm going to try 1,000 over 3. And then I'm going to minus. This is just 50, right? 100 squared over 2 is just 50. So I'm going to subtract 50. Close bracket. Minus. Second one now. This is another fraction again. I have 3 times 5 to the 4th power over 4. Oh, I need a bracket on this first. I'm subtracting everything. So I need a bracket right here. Good. I've put in the bracket. Then I'm going to plus. This is 5 cubed over 3 fraction. 5 cubed is just 125 still. If I want to put it 5 cubed over 3. And then I'm subtracting. Well, 5 squared over 2 is just 25 over 2. And then I close my bracket and I get that. That is 7 equals to 7, 2, 8, 5. This is to the nearest whole number, right? Centimeters is the distance we travel. That's it. Any other question anybody have? Anybody else? Anybody have any question? Joshua, have any question? Carl, have any question? Tavon, have any question? Nobody have any question? We can go home now.
Not currently, sir, but I do believe that we'll have a few questions.
All right, then. We're going to hold on then, no? I'll just wait here. No problem. I'm working through with you, so I'll just wait. Let me know when you have something.
All right, sir. Tavon just posted in the chat, sir. 2019 number 7, sir.
All right. Somebody will watch the chat because I can see it, right? Because I'm seeing what you are seeing on the screen. Okay. 2019 number 7. All right, cool. 2019 number 7. Bring it up here this way. 2019. Number 7. Oh, the last question. Last question. You must have the second to last question. What is it? Number 7. Number 7. Okay. This one. Okay, I forgot that in 2019 it was the old syllabus. All right. This question gives us the weight in kilograms of students in grade 5 are displayed in the following stem and leaf diagram. So they give girls on one side and boys on the other side. Boys and girls. And they tell us the key. So the boys are read this way and the girls are read that way. That's why this is 28 going so and this is 28 going so. All right. Question says state the number of students in the class. So basically I have to add up all these values on that side and that side to get the total number of students in the class. So let's just do a quick recap of it. So in terms of how many students is on each line, So on this line I have 5 students total, 5. 3 over here. In fact, I might need to know how many girls and how many boys separately. So let me do it separately. So I have 2 on this line. Then I have 3 and 2, 5 on this line. Then I have 1, 2, 3, 4, 5, 6, 7 on that line. 7 on this line. Then I have 1 on this line. What that add up to? That add up to 15, right? Add up to 15. Yeah, 15. Then that's 15 boys. Then on the girls' side, I have 3 on this line. Then I have 1, 2, 3, 4, 5, 6, 7 on that line. 7. 1, 2, 3, 4, 5, 6, 7 on that line. 7. 7 here. Then we have 1, 2, 3, 4. So we have 4 on this line. For a total of what that now? 24, right? No. Yeah, 24. So much for this? No, man, something wrong. I put 14, should I put 4? I think in ahead, you know. My brain calculated the 14 already. It's 14. As I put 14, my brain already calculated the 14 here. 14. So the total number of 29. So there are 14 boys plus 15 boys. 15 boys plus 14 girls. It's 29 students. Now you can just count them off and write 29 and go boy business rather than do all of this breakdown like me, right? Because 1 mark for it. In the exam, you just want to count. You just count off how much over here, count up how much over there, and that's it. All right. Then it says, construct the box and whisker plot for the entire class. So to get the box and whisker plot for the entire class, what do you need? You know, you need the smallest value. You want the smallest value, the low. You want the Q1. You want the Q2. You want the Q3. And you want the highest value. All right. Now, when it is like this on a two-sided, you kind of have to be careful. Now, since there are 29 values, like you can divide it 14 and 14 and 1 in the middle. I'll show you, okay, you have 15 on a side and 14 on a side. So the median is one of the values. All right. Remember now, you're going to count off to find. So which value is the median? The 15th value is the median. The 15th value. 15th value first is the median. Now, maybe if I was in the exam, I would have rewrite that and put a one, maybe put it up here, so, and put all my values, one stem, one side. Don't put no two-sided, no, and work with it that way. Because if you're doing it this way, you have to concentrate and focus. But I might have done that in the exam room. That's my preferred way to do it. I'll just take this and just rewrite it. And just put one. Just write a stem and leaf for the students, and don't bother with no boy and girl. No. I don't want the median for the work club. But let's try. Let's see if we can do it from the two sides. So I need a 15th student. The 15th. So maybe we have to count in ascending order. So the first line of all the lowest values, and you count into the 15th student in ascending order of the values. So this is 1, 2, 3. Those are the 3 lowest values. 3, 4, 5. Then you come to 6, 7, 8, 9. And this is the 10th one. 11, 12, 13, 14. So therefore, this is a 15th value right here, so which is 39. But can I agree with that? But good at that?
Yes, sir.
Yes, sir.
All right, so that 15, that's my Q2, right? My median, that's my Q2. So I know already. I need a lot of those values. So we usually find them in that sequence, Q2. So Q2 is 15. So we can write that. All right, let me just put these there and put the value below them, and then we'll draw the box and we scap plot after that. So let's put these here. So we have found Q2. So this is what is that? 39. 39. What were these scores again for? Remind me. Oh, the weight in kilograms. So it's 39 kilograms. Then I want Q1. So it's a Q1 now. Remember, I know it's like you take the data and you divide it 14 and 14. And the 15th one is this value right here. So the Q1 now is the middle of these 14 values. Halfway mark of those 14 values. It's going to be the average of the two in the middle. So if you have 14 values, you're going to divide them 7 and 7. But because it's an even number, you have to find the middle, the average of the two middle values. All right, so you have 7 values and 7 values. So you basically need the average of the 7th and the 8th value. Okay, if you have 14 values and you divide it 7 and 7, so 7 up to here, 7 up to here, and 7 up to here. You want the median, you want the average of the 7th one and the 8th one to get the lower quartile, the 7th one and the 8th one from the front. Average of the 7th and the 8th. So you come back on this now and look for the 7th and the 8th, and you're going to average them to get the Q1. Starting from the front. 1, 2, 3, 4, 5, 6. All right? So the 7th and the 8th are these now. See them here? So the 7th and the 8th. Because this is 133 to the 8th, so I never really matter. The 7th and the 8th is a 32 and a 33 from the Q1. 32 plus 33 over 2. That gives you your Q1. Then it's a Q3 now. You're doing the same thing from the back. You're counting the 7th and the 8th value. You're going backwards now. Like you're coming backwards here, so from the back. The 7th and the 8th value from the back give you your Q3. So I'm counting backwards now. So I'm counting down. So I go 1, 2, that's 45. Then this is 42. That's 1, 2, 3, 4, 5, 6, 7, and the 8th value. So the two of them are 41. So this is the 7th value and the 8th value, counting down from the back. 41 and 41. So Q3 is just 41 plus 41 over 2. And the lowest value, look at the table, the lowest value is 28. I'm going to put 28 right here. And the highest value is 51. 51 is the highest value. So that's my data. Now what is work out to? I work out to 32.5. Put up here, so 32.5. And this is just 41. So the values for my stem and now the stem and leaf, the box and whisker plot is a scaled drawing. You can't just draw it random because you have to be able to see the length of the boxes and the length of the whiskers. So it's kind of a scale drawing. So you have to kind of put a little scale. If you want to use a rule and do it, or you just want to kind of roughly do it, you have to do a scale drawing. Well, since you start at 28, I have to start at 0. You can maybe go up by 5. And so, okay, this is 25. Let me go by 5. 25, 30, 35, 40. Maybe make it look wider. 25, 30, 35, 40, 45, 50, 55, 30, 35, 40, 45, 50, 55. All right, let's put in the values now. Let's put them on in purple. So my lowest value is 28. So 28 may be around here. Then my first box, my box starts at 32.5. So 30 and 35 here. So 32.5 is right halfway between them. That's where my first box comes. So I start this way. Then the Q2 is 39. Now 39 is going to be just before this. I'm going to just do it like that. 39. That's about where 39 would be. And then I want 41. So 41 is just going to be right on the other side of the 40 here. So you clearly see that that box is shorter. All right. And then I want 51. And 51 now is all the way out here. So 51 over the 50. So go like that for 51. All right. And I normally just put the values on the diagram itself. So I would go now and put it in on purple just to see. All right. So I would put the 28 right here. Put on red. I'll put the 28 right here for the lowest value. I'll put the 32.5 right here. I'll put the 39 for the median there. Put the 41 for the upper quartile there, and put the 51 for the highest value there. That's how I would do it, right? Put on the values on it. And that's my box and whisker plot. All right. Then now, it says the standard deviation. They asked us to comment on it. Construct the box and whisker plot. They didn't ask us to comment on it. There's a construct. Okay, kind of balance, because the box over here is longer, but the whisker over here is longer. You know, so I don't like when it's like that, you know, clear, you know, skew to the right or skew to the left. But they didn't ask us for the skewness of it. All right, come down here now, and it says the standard deviation of the weight of the boys is this: 5.53. Determine the standard deviation of the weight of the girls and provide an interpretation of your answer. You know, so this is crazy. This is crazy to get the standard deviation for the girls. Nowadays, all they do with this question, they give you the information to calculate the standard deviation. There's a lot of work to calculate the standard deviation, you know. Because the standard deviation formula, if you look at it on the first page, and there are varying ways it can be expressed. Look for the formula up here. This is crazy. So standard deviation is how is here. Now this is a variance. So to get the standard deviation, you basically, and I'm not going to use this method, because this method you have to calculate all the differences and then square it. That's what you have to do. You have to calculate the mean first. You have to calculate the difference between each value and the mean. Add them up, right? And you know, calculate the difference between the mean and all the values. Then you're going to have to square that, each of them, and you're going to have to add them up. You know how much work that? For this method, you calculate the mean, by this question crazy, and you square it. All right. And then for here, you're summing the square of the values and divide by a number of values. I think this one easy. We just need to put a square root over it. This one. And them F business, you don't need them. All right, them one business. So a simplified way of writing this is just write it as the sum of x squared. The F not really needed. You're summing all the x squared values then. All right, sum of x squared over this sum of f is really the n, the number of terms, and then minus the mean squared, and then square root in all of that to get the standard deviation. This with the square, and that is the variance. So standard deviation, now you're gonna have to square all of this to get the standard. So this is what we have to work out, you know. That's what we have to work out for this question. Let's go and see if we can do it. Maybe not so bad. Let's go. I don't think it's reasonable, and I realize it's not reasonable in more recent times. But look at the more recent papers; they just give you what these values are and use them. Because I ask you to work out this, the multiple calculate so many values. It's just unreasonable. It is just unreasonable. Anyway, let's copy this down as a formula. It's unreasonable to ask them to work out the multiple calculation. So I don't think they would do that again. All right, I don't think they're going to do that again. Right, number 7. Unreasonable, 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 unreasonable. Here it is. So this is the formula we're going to have to use. Paste. This is the formula. So first thing you need is the mean, and then you're going to square it. How do we get the mean? If I add up all the girls' values and divide by the number of girls, that is these. Now, some calculators can do it, you know. You put them in and they tell you everything. If I add up all the values for the girls and divide by the number of girls, all right? So make us see if we can do it. Get the mean quick. Then if I add up the square of the girls, I'm just going to do it and just write the value. I'm not going to show the working. All right? This is the calculator. Put them in the calculator, work them out, and things. So to get the mean, I've add up all these scores for the girls. Remember, the girls are working out fine. Give us the boys already. So working out those. All right, see it now. It's gonna be bracket. Don't bracket it up. All right. I don't have to bracket it up. Why am I saying I bracket it up? Because I'm going to divide. I'm going to bracket it up. Bracket. 28 plus 28 plus 29 plus 32 plus 32 plus 33 plus 35 plus 38 plus 38 plus 38 plus 41. No, not 41. 40 plus 40. And there are 2 further ones. Plus 41 plus 41. Then we're going to add 42 plus 42 plus 42. Close bracket. That's the sum of the girls in right up here. So the sum of the scores of the girls. Sum of this x of the girls is 495. And you're going to divide that now by the number of girls. So you're going to divide that. There are 14 girls. So the mean of the girls right now, I even put it up at 14 and keep the exact value. I'm going to have to square it. So that is my mean right now, right? So, right, this is my mean. This is the mean of the girls right now. This question is unreasonable to ask it to do this. So I'm going to copy this down as my mean. I'm going to have to square it. All right, copy, paste it down here. So, all right, that's my mean right here. So this mean value is going to be brought and placed inside there. Now I need the sum of the squares of the girls. I'm going to square each value and add them up, right? So I'm squaring the values and adding them up. All right. So this is when I'm up on the calculator. We can go back now and square them. All right. So I'm going to take out about this, the divide. I'm going to use up my calculator. I'm going to square these values. So square, 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 square. Some of the squares of the values. Square, 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 square. That's it. So I'm getting 1610. I'm writing now. The sum of the squares is equal to 16107. 1610, 16107. Sum of the squares. I'm going to copy this down. Copy. Paste it down here. Alright. So I'm ready for my form, ready for my calculation. I'll paste it to the side. Paste this to the side here. I'm in exam, I'm just working with my calculator and giving them that thing. And they don't even give us the space to do it. So the standard deviation S comes equal to the square root Now the sum of this square is this figure, 16,107. 16,107 divided by the number of values for the girls is 14 minus the mean squared, which is 495 over 14 squared. I'm going to put that in my calculator and get the standard deviation. So clear this now. So I'm going to square root of a fraction 16107 over 14, and then I'm subtracting a bracket, a fraction in there, and it is 495 over 14. Come out of that, close bracket, and that is now squared. And I'm getting 9.98. 9.98 is the standard deviation. 9.98 kilograms. All right, so 9.98 kilograms is the standard deviation. And it is the boys one lower than the girls one, right? And look at it, the boys one is a low value relative to the girls one is a higher value. Let's write lower. And this one is a higher value. But ask us to what? It says provide an interpretation of your answer for the girls compared to that given by the boys. How do we compare these two standard deviations? The lower one compared to the higher one. It's quite simple. The higher one means that the weight of the boys are more widely spread from their mean weight. No, this is the girls. The girls have the higher weight. It's the girls, right? It means that the weight of the girls are more widely spread. Because of higher standard deviation, the weight of the girls deviate more from their mean weight compared to the other boys' weight deviate from their mean weight. The weight of the girls deviate more, or they are more widely spread. If you're referencing the boys, because they have the lower standard deviation, the weight of the boys are more closely spread to the mean weight of the boys. And you have to compare, you have to say it from the mean weight. Because I say standard deviation is a calculation. It's a calculation of variance from the mean. That's what it is. So if you're referencing the boys, or the girls have a higher, so you could say something like the weight of the girls, the weight of the girls are more widely spread from their mean weight as compared to those of the boys. Can I write something like that? So because the standard deviation is higher, the weight is more widely spread. You have to put in this line in your explanation from the mean weight. You have to say from the mean. But you have to ensure that you see this from their mean weight, because standard deviation is measuring variation from the mean. All right, that's it. Well, the second part of the question too, don't you say determine number of students in the 20th percentile. So to get the 20th percentile, so it's like how you have quartiles. You have 1/4 of the data. 1/4 of the number of students represents the first quartile, and half of the data represents half of the total number of students. So the portion of Q1 is 1/4 times the number of students, basically, on average, right? So the 1/4 of n plus 1. But it's a 1 quarter thing, right? They divide the data into quarters. It's a percentiles, you divide the data into 100%. It's like I take the data and divide it to 100%, split up into 100%. And you want to know what the 20th one is. What position is the 20th one? All right? And what is the score of the 20th one? Now there are 29 students. And you're going to go to the nearest whole number. There are 29 students. You want to know which student is the 20th in the 20th percentile and see what score he has. Just like how when you're doing the quartiles, you find the position first that the first quartile is in, and you find what score that is. So in terms of percentiles, right, is 20%. So you want 20%. You want to know what position is 20% of 29 students in ascending order. So you can write that out and go to the nearest whole number. 0.2, 10% is 0.2 times 29. Talking about 5.8 student, which is approximately the 6th student. The 6th student has a score, which is the 20th percentile score. All right, the 6th student has the 20th percentile score. The 6th student in the data. All right, and I want to know how many above. Determine the number of students above the 20th percentile. All right, determine the number of students above the 20th percentile in the class. So let's see what score is the 20th percentile and see how many students are above that. Remember, some of the scores repeat, you know. That's the key thing. Some of the scores repeat. So let's see what the score the 6th student have and see if any other student above him have that. You can't include them. Whatever score the 6th student has, all the other students who have that score are also 6th percentile students. If you understand what I mean. So I'm going to look at the 6th student has, what score the 6th student has. All right. And the student are just the boys. Them say boys or girls. Let me see. If them say boys. Students, right? So it's all of them, student. So the 6th student, we'll see what score the 6th student has. And see if there are any other with that same score and want the ones who got above that score. So counting of the students. 1, 2, 3, 4, 5. See the 6th student here. So the grade or the weight of the 6th student is 32. So you want to know how many people weigh more than 32. That's what you want to know. So this is another 32 right here. So it's another 32 right beside it. So you cannot include these. You want all who above. So how many students are in all? 1, 2, 3, 4, 5, 6, 7. So 7 students falls on the 20th percentile or below. 7 students. And therefore 22 students are above. If you add up all of these above, you're going to get 22. All of these 22. So you can do it by saying the 29 minus 7 students up to the 20th percentile. So it's 22. 22. Right? So the percentile mark is 32 kilograms. So you can say i.e. 32 kilograms is the 20th percentile weight, right? And the number that is greater than 32 kilograms is 22 students. 22 students. You cannot include them. The ones you don't include ones who get 32 because it says above. So 22 students. That's it. Next part. You want down here, Sato? Want down here, Sato? First to ask for the question. Answer in the chat. First one. Say yes?
Yes, sir.
All right. It says a vendor. Has 15 apples on a tree, 5 red, 6 green, and 4 yellow. A customer requests 3 apples, but does not specify a color. Determine the probability that the apple chosen contains one of each color. All right, so you want the apple to contain one of each color. All right, so I'm going to think of it as if you're picking all the apples and you can get them in any order. You don't specify a color, but I want to get them in any order. So what are the possible ways you can get 3 different colors? You can get a red, then a green, then a yellow. Or you can get a red, then a yellow, then a green. Or you can get a green first, then a red, then a yellow. Or you can get a green, then a yellow, then a red. Or you can start with a yellow. You can get a yellow, then a red, then a green. Or you can get a yellow, then a green, then a red. What are the possibilities? That's the possible combination that you can get the 3 colors. Now remember, after you take it out and then I replace them, you know. So this is picking them out and not replacing them. So there are 1, 2, 3, 4, 5, 6 possibilities. What's going to happen is that each of them is going to be the same probability. And it is or. So you get this, or this, or this, or this, or this, or this. And so you're adding the probabilities. Let's do this one first and see what it works out to. You're going to say that the work out to be the same because the numbers are going to be the same value. So you see, the denominator is going to be the same because you keep taking out 1 and the numerator is going to be the same. So we take out the red first. How many apples is there? 15. Take out the red first. That's a 5 out of 15 probability. Then if you take out the green next, you're going to have 6 green left in there. So you're going to be a 6 out of 14 probability. 6 out of 14. 14 left. And then if you take out a yellow, you're going to get 4 out of the 13 left. That's the probability of getting this. All right. Let me shift this down a little bit so we have a little bit more space. Shift this down a little bit. Then the second possibility is that we're taking out the red first again. So you're going to get 5 out of 15 or and when it's and they multiply the yellow now. Yellow is 4 yellow. So you get 4 out of the 14. But they're going to have 6 green left. So they're going to get 6 out of the 13 now. See that's what is happening? So you're getting the same numbers on the top and you're getting the same numbers on the bottom each time. Because you keep reducing the number and you keep getting the same you're getting each thing once. It's just that the different ways you can get them out of the back working at, right? Because they didn't say you must take out the red first or whatever. And so looking at all the possible ways we can take them out. Right? So these are all the possible ways that could come out of the bag. If you look at the third one, let's do the third one and then we realize the pattern. So if we take out the green first, you're gonna get 6 out of the 15. And then you can take out a red. So it's still 5 red out of 14 left. And you're taking out the yellow, it's gonna have 4 out of 13. So you realize that all of them coming out to be the same. Each of the probabilities coming out to be the same, and there's 6 of them. So the answer for this, all of this becomes 6 times one of this. By adding them up, right? Probability means that you're gonna add them because it's R. Each of the R is a plus. So you're gonna get 6 times the 5 times. I can just put them in ascending order, the values. 6 times 4 times 5 times 6 over 13 times 14 times 15. Whatever that work out to is a probability. So let's run it this way. So we work this out. Here. We're gonna get 6 times a fraction of 4 times 5 times 6 over another fraction 13 times 14 times 15. As a fraction, that would be 24 over 91. 24 over 91, that is it. All right. Next one. Probability of getting all three the same. So to get all three the same, it is either you get a red, then a red, then a red, or you get a green, then a green, then a green, or you get a yellow, then a yellow, then a yellow. All of these, you're going to have to add them. You work out what this one is, work out what this one is, work out what this one is, and you add them. All right, so red or red or red. How much red to start with again? 5 red, right? So probably to get a red. 5 red is 5 out of 15, then 4 out of 15, then 3 out of 15. That's a red to get 3 reds. Then to get the 3 greens, what green start with? Green start with 6. So you're going to get, no, not 15 or 14. These are supposed to be reducing, my mistake. I take it out, the number I'm taking out from is reduced. So it's 14 and 13. All right. Then for this line now, the green, you're going to start with 6 green. So you're going 6 over 15 first. And then you multiply that by 5 over 14. Then you're going to have 4 left, which is 4 over 13. And then the last one, the yellows. How many yellows were there again? The yellows were 4. Start with 4. So you're going to get 4 out of 15 first. And then you're going to get 3 left out of 14. And then you're going to get 2 left out of 13. So you're working out all of this. This plus that plus that. So if you notice, the denominator is the same for all of them, right? So the denominator, if we go back here, is the same for all of them. I can throw out the numerator, we can add them up. So it is 15 times 14 times 13. So the denominator is 2730 for all of them. All right, so plus denominator is 2730, and then plus, we have to put equal, and these are gonna add up. So this one is this one is this. Denominator is 2730. The numerator is just another one. 5 4 is 20 times 3 60. And this is 6 5 are 30. 30 times 4 120. And this one 4 3 is 12. 12 times 2 is 24. So the answer, add up all of these and put them on that common denominator. You add them up. So you're gonna add up fraction. You're gonna have 60 and 120 and 24. And it's all going over 2730. And let's see that as a fraction. 334 over 455. You have to add up these probabilities, or means that you add the probabilities. That's it. That's an easy. Anybody else? Anybody else have a question that I want to do? I'm not gonna ready for tomorrow, man. Nobody have a question. Oh, good and ready.
Third,
Yeah.
you're live right now, right?
Huh?
You're live on YouTube right now?
Yeah.
Yeah, somebody was asking if we could do number 6 on 2023.
Number 6 on 2023.
Yeah.
All right. 2023, number 6. 2023. I know so that video is there. There's a video on the same channel. Number 6. 2023, number 6. There's a video there. That very question. Which one is number 6? Oh, further down here. After this. After that. Oh, this one, statistics again. All right. Let's go. So this one says, the following stem and leaf diagram represents a score out of 80 obtained in an additional math exam. All right. So these are the scores out of 80. Remember, I said this, for example, means 30. And this, for example, means 53. Normally, they would give a key, but they didn't give any key. So this value, for example, right here, really means 56. 5 and the 6, right? 56. So the lowest score right now is 30, and the highest score is 79. All right, question says, write the raw data set that was used to construct the diagram. So basically, I want to write out all those values. Yeah, that's what it is. To list all those values. All right. So this is 30. Let's write them out. See if we can fit them on a straight line. Let's see if we can fit them in one line. You might have to write two lines, but I want to fit them in one line so I can divide it up if necessary. And show the quartiles and all of that, right? I'm going to try to fit them in one line. So lowest value is 30. Then 33. Then 37. We'll go to the 40s now. 42. Then 44. Then 46. Then 47. Then 49. Go to the 50s now. 51. Then 53. Another 53. Then 56. Then I go to the 60s now. Can't hold. Then we go to 60. Then 67. I make this smaller because I want everything to fit in one straight line. If you can't fit it in one straight line, all you have to do is put it in two lines, right? But I want to fit it in one line so I can show you how I can break it up. Where we reach this 67 right here. So another 67. Then we have 71. And then we have a 79. And I hope I didn't miss out any. You can count them off. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 values. Make sure I have 17 values here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Good. So we didn't miss out any. So since there are 17 values there, nice. The data can be divided up easily. Means that the middle value is the median. 17 values can be divided 8 and 8, and then the 9th one in the middle. As 8 and 8 are 16. 16. The 9th one is a Q2. All right. So one of the values can be a Q2. Nice. Anyway, let's continue. It said determine the following measures from the data set. The median. The median is the one in the middle. So I just show the 8 and 8. So 1, 2, 3, 4, 5, 6, 7, 8. So my bottom half is right here. Use a red color for that. Bottom half stops at the 49, right? Dividing up the data half and half. So this is my bottom half. When the data is odd, one of the values is the median, which is this one in the middle right here. And then you have a top half with 8 values. 1, 2, 3, 4, 5, 6, 7, 8. Good. Just checking the consistency of everything. So my median is this score right here, so 52. What is the data in? The data is just scores obtained, no measurement, no, right? So that's 52. So that's 52. 51, sorry, 51. All right, scores obtained. All right, that's the score is 51. What is the mean? So to get the mean, you're going to add up all those values and divide by 17. All right, so I'm going to say the mean is the sum of x divided by 17. All right, and we're going to calculate the sum of x with the calculator and then divide it by the 17. Don't like when they give this, but we just have to do it. Telling students in an odd math exam to add values does not make no sense to me, but such is life. All right, so I'm going to add up all those values. So I'll just add them up correctly. All right, let's add them up correctly and don't give it away. All right, I'm going to put a bracket. So it's 30 plus 33 plus 37 plus 42 plus 44 plus 46 plus 47 plus 49 plus 51 plus 53 plus 53 again plus 56 plus 60 plus 67 plus another 67 plus 71 plus 79. 885 over 17 scores. When divide that by 17, I'm going to get 52.1. Put it to one decimal place. So I'm going to shift this down a bit. And let's put three significant figures, So I'm going to put 52.1. There are no measurements, there are no units on the data, so I'm just writing that. This one now says, what are the modal scores? And I put scores, because you can have multiple modes in data. So, and there are multiple modes if you're looking for the score that occurred most frequently, right? So, there's a repeat value here, and there's a repeat value here, and the two of them repeat the same number of times. No, not that one, sorry, here, 67. All right, so there are two modes, 53 and 67. They occur an equal number of times. So it's 53 and 67, two modes. It's bimodal. 53 and 67. Those are my modes. All right, and this one says, and they're helping us to calculate these things. What I told you, the recent paper give you these things. So the paper that we did a while ago, we have to be working on those things. And this recent one give you. But look here now. So the 885 that we just worked out a while ago, it was there on the paper. And we had to work it out. So see wicked. Come after we work it out, Coming apart after we had to work it out. So just as how they gave it to you here. They could have given us to us here too. To work out the mean. Tell you what I'm wicked. Anyway, so there you go. So this one says now, given that the sum of the x is this, so that means that we're going to be using this formula, and they have to use the formula or they put it. So remember, the standard deviation can be arranged multiple ways, right? So they want us to use this formula. So the sum of x is this. So this value is coming right here for the sum of x. Sum of x squared, sorry. And then now the sum of x is this, but here we want the sum of x all squared. So I'm going to put this value inside this and square it. And then the n is 17 here, and the n is also 17 here. So here's just a matter of putting in values, guys. So this becomes equal to the square root. The sum of x is this. I'm going to put that there, 48999. I'm going to subtract, and there's a sum of x squared. So I'm squaring the sum of x. So it's 885 squared. I'm dividing that by n, which is 17, and I'm putting everything here over 17 minus 1. That's what I'm calculating. And we don't need to working out piece by piece and part by part. Just do one calculation. Use the full capabilities of a calculator. I'm just going to put everything there in my calculator and get one value equals. So it becomes a big square root, then a fraction, then I have 48999, then I'm subtracting another fraction, and on there I have 885, and I'm squaring that, then I'm putting that over 17, and I come on the denominator there, and I put 17 minus 1, which is 16, and I get 13.5. That's my standard deviation. And this was a free 4 marks because they are substituting values that they give you in a formula. That was a nice free 14 marks because everybody was supposed to get that right. And then now this says a student needed to score at least half the number of marks possible to pass the exam. Remember, half the number of marks is what again? What was the total marks? It was 80, right? 80. Good. So to score half the number of marks, you have to score 40 or more. Right? So if a student needed a score of half the number of marks, total marks possible to pass, they need 40. So you need greater than or equal to 40 to pass. That's a pass mark. Determine probability that a student failed in the exam. So the ones who failed, to fail means that you need to get less than that 40. So what you need, we need to see how many persons got less than 40 and divide it by the 17. All right? Give your answer to 2 decimal places. So the probability of fail is going to be equal to how many persons fail, how many persons got less than 40. See it here. 40 started right here. These are the ones who passed up here. This is pass. These 3 failed, they got less than 40. So it's 3 out of the 17. 3 failed. So this is 3 out of 17. And I said give the answer to 2 decimal places, so I have to work it out, right? So it's 3 over 17. The 2 decimal places, that is 0.18. All right, that's what that is, 0.18. Next part says, given that a randomly selected student has passed the exam, what is the probability that that student scored over 60? Give your answer to 2 decimal places. There's a conditional probability. So this probability has reduced the sample size to not all the students. We are now taking a probability out of the ones who passed the exam, out of who passed. So we want to know how many students got 60 out of the ones who passed. So this is reducing the sample space to only the ones who passed. I want to know how many persons got 60. So the ones who passed are in this. Our sample space now has been reduced to the ones who passed, which are these. It's not complicated. That's where we want to select the ones who got over 60. Let's say more than 60. Let's say more than 60 or 60 or more. Let's say, down here. Let's say you're choosing from the ones who pass, right? What is the probability that a student scored over 60? So the ones who got more than 60. So how many got more than 60 from the ones who passed? It's a conditional probability. These got more than 60. I'm going to circle in black these. So these passed in purple. And out of the ones who passed, 1, 2, 3, 4 got over 60. More than 60. So like this is a conditional probability. Say, what's the probability that somebody got over 60 given that they passed? So you're reducing the sample space to those who passed, which is those 14 persons. Have just 17 total. We took out 3 down here. So it's 14. So it's basically 4 out of 14. I'm going to pass 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Good. 14. So it's 4 out of the 14. So then it says 4 out of 14. 4 out of 14. That is the answer down here. So 4 out of 14. It is not complicated. This is equal to 4 out of 14, which is 2 out of 7. So we're doing 4 out of 14. I want as a decimal, not 17. 4 out of 14, Mr. Shaw. 0.2 decimal place, 0.29, which is equal to 0.29. I wanted to correct the 2 decimal places. 4 out of 14. All right, this one says, based on the given stem and leaf diagram, describe the distribution of the data. All right, we never draw a stem and leaf diagram, you know. We never draw a box pattern, we have a stem and leaf diagram. So you're supposed to be able to see it from this up here. But a good way to do it quickly is to see the distance or the extreme distance from the median. You can just do a crude way that way. So from this median value to that largest value up here, what is the difference between those two values? And what is the difference down to this lowest value? And the one that is larger is the side that it is skewed towards. So up here, I'm doing 79 minus 51. A crude, like a quick calculation. 79 minus 51, that's 28. So this side is 28 units long in terms of the data. Over here, it's 51 minus 30. 51 minus 30. Over here, it's just 21. So over here, the data is longer. So we are skewed to the right, or positive skewed. Positive. Because the stuff, if you have to draw the box and whisker plot, over here will be longer. All right? Over here will be longer. So we didn't do the quartile, I just did from the median to the last value. All right, so this is positive skewed. Positive skewed or positively skewed. The data is positive skewed or right skewed based on that side being longer. Crude calculation, crude method, but it works as well. So I want to see if this positively skewed or skewed to the right. Positively skewed. Positively skewed. Or instead we could say skewed to the right. All right, down here. It says your friend suggested that a bar graph or a histogram could be used to represent the data. Advise your friend on which graph is better, the better option, and give one reason to support the answer. Now, bar graphs are used for discrete data, counting data. Histogram are used for continuous or measurement data. What we have in this statistics and this data is discrete data. Nothing is being measured. We are counting the number, counting the grades or the scores obtained by the students. All right. So the discrete data is used for on a bar graph. Continuous data is used on a histogram. So because this data is discrete, I would go for the bar graph. So I would say the bar graph is a better option. Bar graph is the better option since the data is discrete. Discrete means obtained by counting. You're counting the marks that they got. Counting data. Counting data. I'm gonna say histogram. Histogram. Let's say histogram are better used for continuous which means measurement Data obtained through measurement. Data. So we're saying the discrete bar graph is better since the data is discrete, and bar graphs are better used for discrete data. End of that question. What good at that?
Yes.
Yes, sir.
All right. Anything else? I don't want anything else.
Sir, could you look at 2017 7A?
2017 7A. 2017 7A. 2017. Where are you, Mr. 7E? All right, this one. All right. This question says the probability of a final year college student receiving a reply for an internship program from 3 accounting firms, QR and SR, 0.5, 0.55, 0.25, 0.2. So it's from Q, R, and S. These are the respective probabilities, all right, of receiving. So if you don't get the reply, it's the other half, the other part that mixed up to 1. It said the probability that the student receives a reply from Q and is accepted is 0.9. So if he's not accepted, it's 0.05 for not being accepted. The total probability must be 1. The probability that the student receives a reply from firm R and S and is accepted is 0.3 in each case. Of being not accepted is 0.7 in both cases as well. Question says, draw a tree diagram to illustrate information above. So the data is not interested in not getting the replies. So we don't need to show that. We need to start with getting the replies from the various places. So starting the tree diagram by showing the stem, showing the branches for receiving replies from Q, R, and S. So we're gonna start here. You got a reply. So this is getting the reply. So I get a reply from Q up here. Maybe it's too long. I get a reply from R. I get a reply from S. So this is a Q leg. Let's look at it. This is getting a reply from Q, and it's a 0.55 chance. All right, I'm getting a reply from Q. Getting a reply from R is a 0.25. So getting a reply from R is a 0.25. And then getting a reply from S is a 0.2. So here I'm going to say getting a reply from S is a 0.2. I'm starting that one, starting it like that. Then after I get the reply, it is either you're accepted or not. So I'm going to break these branches now, accepted or not. All right. And this is going to be again accepted or not. And this one is, it can be accepted or not. All right. So I'm going to use the letter A for accepted and A prime for not accepted. All right. Let me put this a little bit straighter. This one, let's put a little bit straighter out here. All right. Put this one a little bit straighter as well down here. All right, let's put down the probabilities now. So getting a reply from Q and is accepted is 0.9. So let's put over here. So Q and accepted, that's how I'm going to write it. Q and accepted is at 0.9. All right, so this is 0.9. Q unaccepted is 0.9. And not accepted, I didn't have to put the Q now, because I already started with the Q down here. So I'm going to just put accepted up here. So let's put accept. You know, I'm going to put the Q accept. Is that? Then put the Q accepted. Q unaccepted is 0.9 right here.
Sir, it's
right.
0.95.
95, all right. 0.95. All right, and then if it is not accepted, which is Q not accepted, I'm putting the prime on this. It's going to be 0.05 on this leg, right? Because the total probability must be 1. Then down here now is either you get a receiver from these two is a 0.35 of being accepted, 0.35 of being 0.3, sorry, of being accepted down here. So R accepted is 0.3. Hope you all can see. And R not accepted is 0.7. I'm not going to put the equal. What about the equal? Down here is the same thing. S accepted is 0.3. S not accepted is 0.7. All right. So therefore, we can complete the tree diagram now by multiplying these on the stem on each on each branch. Let's put down in purple. Get a calculator. Let's go to calculator and calculate those values. All right. So here, to get a reply from Q and it's accepted, you multiply those two, right? So it's 0.55 times 0.95. That is 0.5225. 0.5225. Then the other one is 0.05 here. So delete this and put 0.5. Get the reply from Q not accepted is 0.0275. Then this leg right here now is get a reply from R and is accepted. So it is 0.25 times 0.3. That's 0.075. And then this one was 0.25 on that. So it is 0.25 times 0.7. That one is 0.175. 0.175. Then we'll come down here. No, 0.2 times 0.3 is 0.06. That one is easy. And then 0.2 times 0.7 is 0. What is that now? 0.35. Let's double check that. How my brain is going. 0.2 times 0.7. Or 0.13. Yeah, man, no, do something wrong. 0.13. 0.14, sorry. 2 times 7 is 14. And then the other one is 0.2 times 0.3. Yeah, 0.06. All right. So those are the probabilities. The diagram is completed. All right. Maybe I can just shift it over a little bit more. Since I can. Let's put it here a little bit more in the center of the page, like that. All right, that is that. Next part now says the term probability that the student will be accepted at an interpretation program. So to be accepted is one of 3 possibilities. Is it either this or this or this? Those are all the acceptance, possible acceptance. One or the other. This or this, or means plus, or this means plus. So adding those 3 probabilities. All right. So that's what it is. Okay, let's write the values, right? So you can say the probability of being accepted is either you come from Q and is accepted, or you come from R and is accepted, or you come from S and is accepted. The R means plus, and we already worked out the individual, so it's 0.5225 plus the second one, which is here, is 0.075, and the third possibility is this one, 0.06 plus, shift these over, 0.06, and that will give you the chance of being accepted. So it's 0.5225 plus 0.075 plus 0.06. So that's 0.6575 is a chance of being accepted. This is a plus. And this also is a plus. That's that. Next part. All right, this one now. This one says, table 2 shows the length in centimeters of 20 spindles prepared by a carpenter to build a railing for an existing staircase. All right, so these are 20 spindles. Are they in ascending order? That's the first thing I want to see now. Are they in ascending order? Yes. Going up this way, and then you come back and you come back this way. So they're ascending order that way. So you continue from here to here, and then you continue from here that way. Ascending order. All right. Question says, determine the mean. Wicked. To get the mean, you're gonna add up all of these and divide by 20. And then that's what it is. You get it to, you have to just do it. So it becomes the sum of the scores divided by the number of scores, which is 20. So now we're gonna divide by 20. So we're gonna add up those values in the calculator. I'm not gonna show them on the thing, and I'm just gonna add them up in the calculator. So let's add them up over here. So it's 1.5 plus 3.2 plus 6.1 plus 9.4 plus 11 plus 12.6 plus 17 plus 18.5 plus 20.2 plus 24.4 plus 25.2 plus 25.2 again plus 28.3 plus 28.8 plus 29.1 plus 30.4 plus 32.5 plus 34.6 plus 38.3 plus, and the last one is 38.4. Those are all the values. That's 3, no, not 3. That's 434.7 434.7 over 20. So it is 21.735. Since it's exact, is the length in centimeters. I put centimeters on the data, on the results, right? The data is in centimeters, so the mean carries the same unit as the data. So if I write centimeter here, it's the mean length. What is the modal length? What length was repeated? I think it's this one alone, you know, 25.2 centimeters. That's the only repeat I remember. That's 25.2. 25.2 centimeters is the mode length. Next question, what is the median length? Okay, so the median length, no one, the one in the middle. So we kind of divided half and half for us already. So the median is the average of the two middle values, which will be this one and this one. That's gonna divide the first half and half of the table, right? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values here. And since there are an even number of values, you're gonna have to calculate the median by taking the average of the two middle values here and there. All right, so that is it. So not so bad. It's already in ascending order. So the median becomes 24.4 plus 25.2 divided by 2. Work out what that is. So it's a fraction 24.4 plus 25.2 divided by 2. 24.8 and put the centimeters again. These are all scores. They represent the scores, so they carry the same unit. Then we want the interquartile range. So we need the Q3 minus the Q1. All right. So where do we find the Q3 and the Q1? So this is it can be found easily now because this is the bottom half of the data. That's the bottom 10, and this is the top half, the top 10. So we need the median of the bottom half, the middle of this bottom half for Q1. There are 10 values there. So it's like you divide the 5 and 5, you want the average of the 5th and the 6th. 1, 2, 3, 4, 5. So the two middle values down here are these two. Those are two middle values. I have to average them for Q1. And then similarly up, you have to average these two for Q3. All right, two middle values you have to average because there's an even number of values there. So from this, I'm going to find Q1, average them, and from this, I'm going to find Q3. Then I take the difference. All right, let's just work it out here. I'm just going to average them. So it is boom bang fraction 11 plus 12.5 plus 12.6 divided by 2. That's 11.8. And then this Q3, I'm averaging now. Let's just delete the numerator up here. I'm averaging 29.1 and 30.4. So Q3 is 29.75. All right, so I'm doing 29.75 minus 11.8. So this becomes equal to 29.75 minus 11.8. That's that. So I'm just going to subtract 11.8 from this minus 11.8. So I'm getting 17.75. Yes, this is easy to subtract. 17.75. All right, down here it says a school cafeteria sells 20 chicken patties, 10 lentil, 20 chicken, 10 lentil, and 25 saltfish daily. It says on a particular day, the first student orders 2 patties but does not specify the type. It says the vendor selects 2 patties. The vendor randomly selects 2 patties. So you're going to select the 2 patties and not going to replace them. Calculate the probability that the first patty selected was saltfish. Calculate the probability. I don't wonder why it's 4 marks for this. Calculate the probability that the first patty selected was saltfish. All right, so it's 2 patties they're selecting, right? So what are the chances of getting? What are the various ways they can select? The patty so that the first one is saltfish. It's 2 they're selecting. You know? So that I'm select a saltfish and a saltfish, or I want the first one to be saltfish, or a saltfish and a chicken, or a saltfish and a lentil. Those are the possibilities. I'm going to get the patty, not going to replace them. The R means plus. So this one is going to be saltfish and then a saltfish. So saltfish is 25. So it's 25. What the total is, by the way? This is 30 plus 25. That's 55 parties initially. So it's 25 out of 55 first. You want another saltfish is 24 out of 55. That's the first possibility. Or means add. You're gonna plus. All right, and put a plus right here.
Wait, sir.
Plus. Yes.
Since both of them are saltfish.
Oh, this
wouldn't
was a
you-
54. 54.
Yeah.
54. Sorry, 54. My mistake. 54. Thanks for that. All right. Then the next possibility is 25 out of the 55 times. They want a chicken, all right? So you could get a chicken next, which is 20 out of 54. Then you could get a starfish first again, which is, so it's a plus. So it will be 25 out of 55 times, you want a lentil now. So the lentil is going to be 10 out of 54. So those are the possibilities. Add them up and put equal. So in each case, the denominator is the same, right? 55 times 54. So the calculation becomes basically a fraction. The denominator is just 55 times 54. The numerator now becomes the sum of this product, and that product. So we're going to have 25 times 24 plus 25 times 20 plus 25 times 10. So the probability is that thing, if I look at it as a fraction, it is this number, which is 133 over 297. That's probability of getting a saltfish first from your two picks. All right. Given that the first party was saltfish, calculate the probability that the second party is not saltfish. All right. So firstly, you are now reducing your chances to be taken out of this. The first party is a saltfish. So you're reducing your sample space to this probability. So you want to know, you want this. So again, given that the first saltfish, the first party was saltfish, calculate probability that the second party is not saltfish. So if it's not saltfish, it's one of these. All right. So it's basically then, you can look at it two ways, you know. You can look at it to say, okay, given that the first party is saltfish, what's the probability is that the second party is saltfish, and then you subtract 1. But it can be that you look at it as the first one is saltfish. So it's basically, this is a sample space that you're working with. And for it not to be saltfish, is these. So it's really these out of the total. That's what they're calculating. Because these are the ones that when it is not saltfish, and this is a total probability for it to be saltfish, the first one to be saltfish. Let's look at it again. Given that the first party is saltfish, meaning you're now reducing the sample space to these. These are a sample space now. That's a sample space. So basically, this is where you're taking the probability out of. All right. Given that the first party was saltfish, calculate the probability that the second party was not saltfish. And this is when the second party is not saltfish, which is this or this. So basically, it becomes this or this out of this. That's what it is. This or this out of everything. That's what it is. How much of this is in all of this? That's what we're calculating. All right. So it becomes this. It becomes 25 over 55 times 20 over 54 plus this one, not saltfish. 25 times 10 over 55 times 54 times 54 over everything that this would be, which is this 113 over 297. That's what you're calculating. You have reduced your sample space to this. So that's what you're working out. So let's set it up. I could have done for the second one to be starfish and subtract 1 from it. Could have been 1 minus this over that. Could have been done that way as well. But let's do the actual thing. So it's going to be a fraction. And we're gonna have I'm gonna put everything in the calculator as this, right? So on the numerator here, the denominator is gonna still be these. Right? It's still gonna be that, which is a fraction and a fraction. So another fraction on top. Yeah, fraction on top. There's gonna be 25 times 20 plus 25 times 10. Two of them over 55 times 54. And you're putting that now over a fraction, which is 113 over 297. That is what you get. Equals 0.664. That is the answer. Okay, maybe look at it as a fraction as well, which is this 75 over 113. So let's put that 75 over 113. That becomes equal to 75 over 113. That is that. Question done. All right. Anything else? Anybody else?
So number 6 for that paper too.
Number 6 on the same paper?
Yes, sir.
Number 6 on the same paper. Number 6. Okay. Right here. All right. Let's go. This question says, show that this integral is equal to that. So, easy, nice question when you give you something to do and you tell what the answer is going to be. All right, it's already. So it is equal to, okay, so the left-hand side is equal to, and start working what it's going to be. The left-hand side, which is this side, is equal to, we're going to integrate now. When you integrate sine, you get minus cos. Because when you differentiate cos, you get minus sine. So you're going to get minus cos x. When you integrate cos, you get sine. Because when you differentiate sine, you get cos. So it's going to become plus 4 sine x between the limits of pi by 4 and 0. Don't assume that 0 gives you 0. Remember, the cos of 0 is 1. So don't assume that 0 gives you 0. It's a common habit. Once you deal with trigs, indices, for example, remember that, for example, 2 to the power x, 2 to the 0 is 1. So don't always assume that 0 is going to give you 0. Cos of 0 is 1. So don't assume that 0 is going to give you 0. Work it out. I'm going to put in the values now. Put in these first. Putting that in these first. The first bracket, I'm going to minus cos pi by 4 plus 4 sine of pi by 4 in the first bracket, minus, put in the second value now in the bracket, minus cos of 0 plus 4 sine of 0. Now it would be nice to know, good to know, that the sine of pi by 4, which is 45 degrees, is the same as the cos of pi by 4, which is the same as root 2 over 2. Some calculator will show you, but it's good to know without and don't need to go to the calculator. So this is root 2 over 2. This is root 2 over 2 as well. All right, but let's write it out. So then, if you don't know, you put them in the calculator, all right? Alright, so this becomes equal to, this is root 2 over 2. So I get minus root 2 over 2 plus 4 times, this is also root 2 over 2. Root 2 over 2 in the first bracket minus the cos of 0 is 1 plus the sine of 0 is 0. The sine of 0 is 0, so this becomes 0 plus 0. All right, and I'm supposed to get this thing up here. Let's see now. So look at this now. So this becomes like 4 of this minus 1 of that. So that's 3. 3 root 2 over 2. The denominator is the same. So this becomes 3 root 2 over 2. Let me see what they give us to prove that thing. This becomes 3 root 2 over 2. This becomes a plus 1 plus 1. This 1 is the same as 2 over 2. So it becomes 3 root 2 over 2 plus this 1 is the same as 2 over 2. They have the same denominator now. Consolidate. 3 root 2 plus 2 all over 2. That's what they said to show right here. Same thing. Shown. We could say QED. All right, down here. Determine the equation of the curve whose gradient function is that and which passes through this point. So it's like a known condition, known values. This is for you to find the C value after you integrate. But you don't have to actually find the C value when you integrate. You know? So dy by dx is this. And it means that dy, or we can say it means that y is equal to the integral of x plus 2 dx. But I'm going to show you a thing now, guys. I'm going to show you something now. Quick and fast. It means that dy is equal to x plus 2 dx. And then we integrate both sides. Watch carefully now. Integrate this side, integrate this side. Now, since there are no values there, it's almost as if we're integrating 1. All right? And then now, I can apply these limits, I can apply these limits on the integral and avoid the need to calculate a C. All right, we're going to do it now. So in this pair, the x is 2 when the y is 3. That's what it means, you know. The x is 2 when the y is 3. X is 2 when the y is 3. I can plant these conditions on the base of my integral. So this 2 goes on the base of the x integral. I'm going to put the 2 here. And the y goes on the base and the lower limit of the y integral. I'm going to put the 3 here. Then I'm integrating to an upper limit of x on this one, x, and to an upper limit of y on this one, y. That way I don't have to calculate the c. The c will be worked out by itself. I don't have to calculate the c. I will get the equation straight by doing that. So this is a way of avoiding the need to calculate the c. But if you're comfortable calculating the c separately, no problem. So when I integrate this dy, 1 with respect to y, I'm just going to get y between y and 3 equals, integrate this now. Integrate the x, I'm going to get x squared over 2. Integrate the 2, I'm going to get 2x. But because I'm integrating with limits, I don't need to put no c again. The c, it kind of work out itself, x and 2. Because when I plug these values in there, that is how I've gotten the c anyway. So it kind of work out itself in there. So this side becomes plug in the y, I get y, minus plug in the 3, I get 3, so it's y minus 3, equals, plug in the x in this, I get about the same thing, which is x squared over 2 plus 2x, minus, but I need, where's my 3? I need to plug in my 3. No, my x was 2. Sorry, my x was 2. Suppose it'll be down here is 2. 2. So I'm going to plug in my 2 now as my lower limit. When I plug in the 2 now, I'm going to get 2 squared over 2 plus 2 times 2. And I plug in the 2. That gives me the equation without working out the c separately. The c is worked out indirectly by doing it this way. But if you're comfortable working it, get it without limit and do your c and then calculate the c, no problem. The answer is going to be the same. So I'm going to work out what this is. So this right here is a 2 plus 4, that makes 6. That's a negative 6. And then this come over and add to it. I'm having negative 6 plus 3. I'm getting negative 3. I'm just working out what the y is going to be. All right. So the y here going to be equal to all this expression. If my c working out, you know, this is going to be these values work out to my c, you know. So I got my c indirectly. So y equals x squared over 2 plus 2x. I'm going to consolidate these values. I'm going to get my c. Let's check it again. This becomes 2. This is plus 4. But they are being minus. So I'm getting a negative 6. Then this 3 goes on become a positive 3 plus 3. That gives me negative 3 right here. That gives me negative 3. So let me erase these now. So if you work out the c the normal way, you will get that negative 3. That's my equation right there for that one. All right. So it can be done this way as well. Down here, I want us to integrate this. Now, because this is a square, I can expand it out into separate terms and integrate it. But I can integrate it as a composite function as well. So this will become equal. I'm going to do it both ways. So it will become equal to integrating as a composite, as if it is x to the square first. So I put by the whole thing, which is 4 minus x all cubed, add 1 to the power, divide by the new power. But you have to remember to divide by the differential of what's inside the bracket, if it is a constant. When I differentiate what's inside the bracket, I'm getting negative 1. I have to divide by the negative 1 as well. And that is going between the limits of 2 and 1. And then now it's a matter of applying the 2 and the 1. Now this is a negative 1/3. So I can factor it out here, the negative 1/3. Negative 1/3 into. And so I'm just working this now with the 2 and the 1. So this first becomes, put the 2 here and get 4 minus 2. 4 minus 2 is 2. 2 cubed. So I'm getting 2 cubed. Minus, put the 1 here now. I get 4 minus 1 is 3. 3 cubed. 3 cubed. And I'm working this out. This is 8 minus 27. So I get negative 1/3 into 8 minus 27. So I get what? That's negative 19 and 3. Negative 19. No, positive 19. Because negative, no positive. So I get positive 19 and 3. Let's do it the other way. We expand it out. So this is just one way to do it, right? Integrate it as a composite. The composite expression. The other way is to expand this out into separate terms and integrate it term by term. So I'll write the integral initially, doing it another way. I write the integral as 1 to 2 and expand this out into separate terms. The 4 squared is 16. Then twice the product of 2 give me negative 8x, negative 8x. And then we square the negative x, I get positive x squared dx. I think this is a long way. I'm going to integrate this now. So I'm going to get 16x minus, when I integrate this, I add 1 to the power, divide by the new power. It's going to give me 4x squared. So I'm going to get 4x squared. For this one, I'm going to add 1 to the power, get x cubed, and divide by the new power, which is 3. And this is being integrated between 1 and 2. I'm going to substitute the 2 in there first now. Okay, and after let's put the values. So 2 into this one, give me 32. 16 2 is 32. 2 into this one, give me 4 times 2 squared, which is 4 times 4 is 16. 16, so I'm subtracting 16. 2 into this one gives me 2 cubed is 8. 8 over 3. The first bracket minus. The second bracket, I'm substituting 1 now for each value. 1 into here gives me 16. 1 into here gives me negative 4. 1 into here gives me 1 over 3. Work out the values now. All right. What do I get? All right. Firstly, this negative 16 and this negative 16 balance with that 32. So that number's gone. So I'm left with 8 over 3. Something wrong, you know. I'm saying make a mistake over here, so somewhere I'm not getting the same answer. Not getting the same answer. Something is wrong. Something is wrong. 4 minus x or minus. Let's double check it. Something is wrong. 2 first. That's 16 plus 8. All right. Integrate this 16x. Integrate this 8x. X cubed 1 3. Did I expand it properly? 4 2 is 8. Just double check it because I'm not getting the same answer. 32 minus 4 8. Everybody say a mistake? Put in the one, I get 16 4 1 and 3. This is minus 32 minus 16 minus 16 is minus 32. Get that. So I get 8. I get 8 over 3 minus 1 over 3. I'm getting 7 over 3 here. So let me check this one over here. See, make a mistake somewhere. So I add 1 to the power, divide by a new power, divide by minus 1. Take this out and the minus 2 third. Plug in the 1 first. I get, plug in the 2, I get 2 cubed. Minus, plug in the 1, I get 3 cubed. 2 cubed is 8. 3 cubed is 27. Make a mistake somewhere, not seeing it. That's 8 minus 7 is negative 19. Minus give a plus. I'm not seeing a mistake. I make a mistake somewhere, not seeing it. Anybody see a mistake? Negative a third. When I square it, 4 4 is 16. 4x times 2 is negative 8x plus x squared. And I integrate, I get 16x, 4x squared. That will give me x cubed over 3, plug in the 2. 16 times 2 is 32. Then 2 there, 4 4 is 16. Then 2 cubed is 8 over 3. Then I'm subtracting the 1, 16 times 1. Then I'm subtracting 4. Then I'm adding a third. And then it is 32. I don't understand it. I don't understand it. I need to do it over. Nobody say a mistake here, so there must be a mistake. I'm not getting the same answer. Not getting the same answer, guys. I'm gonna do it over from scratch. Because I'm not getting the same answer. Do it over both ways. Take my time if I'm rushing too much. Let's go again. This one. So I'm gonna add 1 to the power. So it becomes equal to in the box 4 into it as a composite 4 minus x. 4 minus x all cubed, add 1 to the power cubed, divide by the new power 3, then divide by differential of what's in here, that's negative 1 between 2 and 3. I'm going to leave the negative 3 here this time. All right, equals, plug in the 2.
Wait, sir, the limits are 2 and 1.
Yeah, 2 and 1. That's not the mistake though. Plug in the 2 here. I get 4 minus 2 4 minus 2 is 2. 2 cubed. So getting 2 cubed, but 2 cubed is 8 over negative 3. Let's do that this time. Minus, plug in the 1. 1 right here. I get 4 minus 1 is 3. 3 cubed is 27. 3 cubed is 27. I know that it's 27 over negative 3. That becomes negative 19 over negative 3. That becomes 19 over 3. Same thing. Let's expand it out. I'm not seeing why the expanded form not working. That's 19 over 3. I'm going to expand this first. So it's going to become the integral from 1 to 2. Perfect square. 4 squared is 16. Twice product of the 2 is negative 8x. Second term squared is plus x squared. That is what we're integrating now. Expand it out. Integrate. Integral of 16 is 16x. Integral of this, you add 1 to the power, you get 2 divided by 2. 8 over 2 is 4. That is minus 4x squared. If I differentiate this, I'm getting that back. This one, add 1 to the power x cubed over the new power of 3 between 2 and the same one. Plug in the 2 first, equals 16 times 2. What is 16 times 2? 32. 32 minus, put 2 here. 2 squared is 4. 4 is 16 minus 16. Put 2 here. 2 cubed is 8. This becomes plus 8 over 3 in the first bracket. Subtract. I'm plugging in the 1 now. 1 here. 16 times 1 is 16. 1 here. Negative 4 times 1 squared is still negative 4. 1 here gives me 1 cube, which is 1. 1 over 3, that's a third. In the second bracket. Why is this not working? I can't see it. This is 16 equals 16 plus 8 over 3 minus, I'm subtracting this, which is 12, and I'm subtracting this, which is a third, minus a third. Why is that not working? 16 minus 12 is 4. That's 4. And this minus that is 7. 7 plus 7 over 3. This 4 is the same as 12 over 3. All right, it worked. I don't know what I did wrong. So that's 19 over 3. I don't know what I was doing wrong the first time. Something was wrong somewhere on the page. Just didn't see it. All right, that is it. So anyway, spent too much time on that one. Couldn't see what I was doing wrong. Could not see it. I could not see it. All right, shift this up. It happens sometimes. It happens. That's all the nature of math is. Sometimes I make a mistake and I just can't see it. I don't know what I did wrong. This one says, calculate the volume of the solid form when the enclosed area by the straight line, which is this, the straight line, and the x-axis, and x equals 0 and 6 is rotated about the x-axis. That's a cone you're forming, you know. You could actually just work it out like a cone, you know, because it's like you have this, watch, y-axis, x-axis, right? And you have this line like that, which is really y equals half of x. That's what that line is. X over 2 is same as half of x. You're going between 0 and 6. So right here is 6. So that is 6. Half of 6 is 3. It means that up here is 3. Up here is 3. right? So when you rotate this about the x-axis, it's gonna form out a cone. It's gonna form out a cone, right? Where the base of the cone becomes a circle of radius 3, and the height of the cone is the 6 out here. The 6. This is the height of the cone. The unit x value here, so which is 6. Volume of a cone becomes a cone. The volume of that cone is pi, a third pi r squared h. Volume of a cone is 1/3 pi r squared h. Let's test it. More math equals better math. It becomes a third. Let's say in terms of pi, right? Did they say no matter? Let's leave it in terms of pi. A third pi versus 3. 3 squared is 9. Let's put 9. And the height is 6 times 6. What do we get for this? We get 18 pi. Because 3 into this goes 2 times 18 pi. So it's in 18 pi units cubed. All right. But let's do it by integration and see. So that is what happened. But let's do it by integration and see. All right. So this is our method. So the method to do it is to use that volume equals pi squared, pi times the integral of y squared dx. And going between 0 and 6. All right. So this is a y. So we're going to square it, right? So the volume becomes pi times integral of x squared over 4. When we square this x over 2, it becomes x squared over 4 dx. This is a constant. We can bring it under the pi there. It's a constant. I'm going between 0 and 6. All right. 0 and 6. So the volume equals, I'm going to move the 4 under here for real. And I'm going to get pi over 4. Then I'm going to integrate the x squared. I'm going to get x cubed over 3 between 6 and 0. Then this 3 can come under here as well. And I'm going to get the volume equals pi over 12 into 6 first. I'm going to get 6 cubed minus the 0 now, 0. Now is 6 cubed over 12 equal to 18? That is the magic question. So it's 6 times 6 times 6, 6 cubed over 12. Is that 18? Yes, it is. Because 2 into this gives me 2 there. And then 2 into this gives me 3. And then 3, 6 are 18. So you see 18 pi. This equals 18 pi units cubed. That's the volume. So if I'm in the exam, I might have given them that method. But they didn't tell me to use integration. But that is it. Because you recognize it became a cone. Because it was a straight line rotating, became a cone. A line that passed through the origin. Right? Which other question? I think I spent too much time on that one a while ago. What time you guys going to sleep? It's now Minister 9 in Jamaica. Here. What time you guys going to sleep? Giovanni, you're good? All right.
Yeah, man, sir, I'm good, man. I'm good, man.
You're good. You ready?
Oh, no, I'm good. I'm good. I'm say what there.
You ready, man? You ready?
No, sir.
Who else have a question? Who else have a question? Send on. Send on.
Could you look at 2019 B and C?
2019.
Number 3, B and C.
Hold on a second. Hold on. Some people in the chat and thing there, they're not asking for any question. You're not asking for any question. They're just chatting. What number is it? 2019?
Yes, sir. B, number 3, B and C.
2019. 2019, number 3. Number 3. This one. Or B you want?
Yes,
B.
sir.
B. That vectors.
Yes,
All
sir.
right. So scalar product is like the easiest thing ever to find. So first I'm going to write these vectors in the column vector form. So you can see the values side by side. Sometimes a lot easier. Just express it that way. All right. So I'm going to write the P as 8, 2. I can write it like the way as well, column vector format. 8, 2. And the Q as 1, negative 4. That's a Q, 1, negative 4. So I want a scalar product. Just multiply these two values and multiply these two values. That is all. So P dot Q becomes equal to 8 times 1, 8 times 1, and 2 times negative 8, 2 times negative 4, sorry. This becomes equal to 0 because 8 minus 8 is 0. Now, once the scalar product is equal to 0, it means that the vectors are perpendicular. State the angle between the two vectors, perpendicular. So it's your since. That's our answer now. Since P dot Q is equal to 0, P is perpendicular. This means perpendicular. P is perpendicular to Q. So the angle between them is 90 degrees. 90 degrees. That's it. That's it. Angle between them equals 90 degrees. That's the answer right there. 90 degrees. This is the answer. All right. Moving along down here. It says the position vector of this vector of A is that. Find a unit vector in the direction of A. The unit vector is the vector that has a modulus of 1. To get it, you divide the vector by its length, by its modulus. So the unit vector of A is written like this with a hat on it. It is equal to 1 over the modulus of the vector A times the vector itself. All right, that's how you calculate the unit vector. How do you get the modulus with these values? It is 1 over the square root of the 4 squared and the 7 squared. You only need to put the minus. 4 squared, 7 squared, and multiply that by the vector itself, which is 4i minus 7g. All right, and what is this? This is let's just put that is 49, and 16. That's 50 and 15, which is 65, right? So that becomes root 65 under here. Root 65 under there. All right, so I'm going to put root 65. So this is root 65. So the result becomes 4 over root 65. 4 over root 65 times I minus 7 over root 65 G. And that is the answer right here. Which one again is it? Said this.
You can do E as well, sir.
Huh?
You can do E as well for 3.
Or A? A? A. All right. This one says a circle passes through, a circle has this as a center and passes through this point. So it's like this. The center is at 1, negative 1, and it passes through a point 43 up here. So the question is asking us for the radius. Radius is the distance between these two lengths. That length is the radius. So let's calculate the length of a line formula for the radius. So the radius becomes equal to the square root of the difference in the x values, which is 4 minus 1. 4 minus 1 squared plus the difference in the y values, 3 minus a negative 1. 3 minus a negative 1 squared. So the radius equals the square root. This is 3 squared, which is 9, plus this is 4 squared, which is 16. 69 is 25. This becomes 5. Radius is 5. Because it becomes the square root of 25, which is 5. All right, this is a 3, 4, 5 triangle. Yes. Next part says, write the equation of a circle in this form. So when you have the equation, when you have the radius and the center, the equation can be written in the form x minus a squared plus y minus b squared equals the radius squared. The a and the b are the coordinates of the center. So because these are the coordinates of the center, it means that the a is equal to 1 and the b is equal to negative 1. So we can drop the r value here and the a and the b value there, and then expand it out to this format. So initially, the equation is going to be x minus the a is 1 squared, plus y minus the b is negative 1. So minus minus becomes a plus 1, because the b is negative 1, and minus minus becomes a plus 1 squared, equals this radius that we calculated squared, 5 squared. But I want it in this, what we call the general form. So this is called the standard form, but this is called the general form. So to get that, we have to expand out this and transpose to make 0 on the right side. So let's go. Expand this first. We're going to get x squared. Let's write that better. X squared minus 2x plus 1. That's what we get to expand that one. Expand this one now. We're going to get plus y squared plus 2y plus 1. That's what we get to expand this one, get that. Then we're going to take this 25 and bring it over here and put it as negative 25. The 5 squared is 25 equals 0. Trying to set up like this. Consolidate now the x squared and the y squared together. X squared plus y squared. Then the x value, this is it, minus 2x. Then the y value, plus 2y, plus 2y. Then the constant values, 1 and 1 is 2. 2 minus 25 is negative 23. Minus 23 equals 0. That is it. That's the answer right there. All right, what else? This part says determine the equation of a tangent to a circle at the point 4,3. Let's copy this diagram down and do it. So copy, paste it down here so we can just have a visual of it. Don't really need it, but it helps sometimes. So the question is asking us for the tangent, right? At that same point, the tangent. So let's put the tangent in red. Tangent will be like this, running and touching the curve there. Let's put T for tangent. T for tangent, T for tangent. So when you have this situation, you need to find the gradient of that tangent because you already have a point that passes through. But you know the tangent is perpendicular to the normal. And when you're doing equation of circles, the normal is the best friend. The normal runs like this. Passes through the center and passes through the point of contact. That's your normal, N for normal. The normal is your best friend because it allows you to find the tangent. It helps you to find the tangent. Why? Because it passes through 2 points that you know. You can find the gradient of it. And it is perpendicular to the tangent. And so you can use a perpendicular relationship to find the gradient of the tangent. So we're going to do the gradient of the normal is the gradient between these 2 points. Which is the difference in the y values. This y value minus this y value. So it's 3 minus a negative 1 divided by this x value minus this x value, which is 4 minus 1. This becomes a positive 4 because it's a plus over 3. Now, ready for the tangent now. So the gradient of a tangent is equal to minus 1 over the gradient of the normal because they are perpendicular. So we can take this negative over 3 and drop it under here. Or to do this calculation, we can flip this gradient and change the sign. Flip it first and get 3 over 4. And because it is positive, the tangent is going to be negative. And so the gradient of a tangent is this. Flip the one that we have and change the sign. So the gradient of a tangent is equal to negative 3 over 4. Then now we're going to use this point that the tangent passes through. Let's call a point P so we can reference it. Point P. So the equation of that red tangent, the equation of the tangent. Okay, so the tangent equation is y minus the y value at the point equals the gradient of a tangent into x minus the x value at the point, using the coordinates of this point and the gradient of the tangent to get the equation. So it's y minus the y value at the point is 3. The gradient of the tangent is this, negative 3 over 4, into x minus x value at the tangent is that 4. Then we're going to write y minus 3 equals, expand this across here. We're going to get minus 3 over 4x. Then this time this gives me a positive because of the minus minus, and the 4's cancel. I'm getting a 3. I could have just taken this 3, bring it over here and add it to that. So what I can do is just change that to a plus 3, remove this 3, and change this. 3 plus 3 is 6. So I'm going to place a 6 right here instead. And this is my equation. Y equals that. Bam. Good to go?
Yes, sir.
All right. What else? Any other question?
So someone was asking to 2018 number 4.
2018 number 4. 2018 number 4. Where are you? All right, let's find it back this way. 2018 number 4, supposed to be here somewhere. 2018, here you are. 2018 number 4. Number 4. Right, this is bare max. Sorry about that. This is bare max. That is bare max. Let me bring it up from here. Bring it up from over here. 2018. Number 4. All right. This is it. Let's find that question. Number 4. Number 4. Number 4. Number 3. Number 4. All right. Nice question, this one. Let's go. All right. Question says, a wire in the form of a circle of radius 4 centimeters is reshaped in the form of a sector of radius 10 centimeters. Determine in radians the angle of the sector, giving you your answer in terms of pi. So this is it. We have a circle. Let's make it a little smaller. we have this circle, and the radius is 4 centimeters. So radius of a circle is 4 centimeters. And this 4 centimeter radius is reshaped into a sector where the radius of that sector is now 10 centimeters. It's a piece of wire now, and the sector angle is theta. The question is asking us to find this sector angle theta. What is common about the circle and the sector is that it's the same piece of wire that was used to make that. It means that the circumference of this circle is equal to the perimeter of this wire. It's the same length of wire. So the perimeter of the circumference of the circle, or the perimeter of the circle, is equal to the perimeter of the sector. So we can say that the perimeter, the perimeter or the circumference of the circle is the perimeter of the sector. Well, let's look at the sector. The radius is 10. So this side is 10. So this side is also 10 centimeters. And the arc length is r theta. The arc length is r theta. The r is 10. To put in the theta in radians, you know, see, in radians, it's in terms of pi, meaning in radians. So this length, it becomes 10 theta, right? Using this, let's put this in red. Let's put that in red. Good. So these are the three sides. This is 10 theta, 10 theta centimeters. So the perimeter is 10 plus 10 plus 10 theta. And the circumference of a circle is 2 pi r, where this is the radius. So I already know. So the circumference of the circle, is equal to the perimeter of the sector. So the circumference of this circle is 2 pi this r. 2 pi this r. 2 pi this r is 4. Equals the perimeter of that thing is 10 plus 10 plus 10 pi. It's on the diagram. So it's 20 plus 10 theta. 10 plus 10, not 10 pi, plus 10 theta. 10 plus 10 plus 10 theta. Question is asking us to find this theta. All right, and want it in terms of pi. So we're gonna do that. So firstly, this can be divided through by what? By 2. If I divide through by 2, we can just transpose and anything. So I'm gonna subtract this and then divide it 10. So I'm gonna get 8 pi minus 20 divided by 10. That is theta. Okay, over the 21st, I get this. Okay, over the 21st, I get this minus 20. And divide under the 10. That leaves me with this. And we can simplify it. Let's make this a little smaller and shift it to the right. And then I'll simplify. So then, from here, we see that the theta is equal to, if I divide numerator and the denominator by 2, divide the numerator by 2, we get 4 pi minus 10. Divide the denominator by 2, we get 5. And that is it. They said in terms of pi. All right, so I'm going to leave it like that. That is our theta. That's it. Nice and easy. Nice and easy. So this became that. So this is the answer. Next part is a different question. It says, solve this equation between 0 and pi. All right, giving your answer to one decimal place. All right. So if you look at this, that's a double angle for cos, and it's a sine squared. Now, this double angle is the most powerful double angle because it can be expressed in multiple ways. It can be expressed cos 2 theta can be expressed as 2 cos squared theta minus 1. It can be expressed as 1 minus 2 sine squared theta. It can be expressed as cos squared theta minus sine squared theta. Now this equation already has an expression of sine in it. So it makes sense to use a format of this that would bring about or be consistent with the sine. So it makes sense to use this format. Okay? That's what we're going to do. One with the sine in it. I already know. So this equation becomes sine squared theta plus 3 of this. If cos 2 theta is this, then 3 cos theta is 3 of this. So we're simply going to multiply these values by 3. So remember, 3 times 1 is 3, minus 3 times this is 6. 6 sine squared theta. That is all equal to 2. Now this and this is giving me a 5 or negative 5. So I'm getting negative 5 sine squared theta equals, I'm going to take this one and take it on this side, and I'm going to get a negative 1. The negative will cancel on both sides of the equation. This negative cancels this negative. Or you could say divide by the negative 5 and get 1/5. So we're getting sine squared theta equals 1/5. To move that square, we're going to square both sides. To move that square, we're going to square both sides. So sine theta is going to be plus or minus the square root of this, square root of 1/5. So at the point now we need to draw the quadrant diagram. I want all the quadrants because we're considering plus or minus. So we want all the quadrants where sine is positive here and here, and also where sine is negative. But question restricted us to this range. And so we don't want these ranges down here. I'm going to cross them out. We don't want down here, because this range is only up to pi right here. So we only want answers in the first 2 quadrants. We have to get the principal acute angle first, which is alpha is sine to the minus 1 of the positive only. The positive only of this value. Sine to the minus 1 of the square root of 1/5, which is the same as 1/5. This is the same as 1/5, because the root 1 is 1. The same as 1/5. I'm going to get alpha with the calculator from here. So when you do that with the calculator, working this out in radians. Where is it? Make sure the calculator is in radians first. Yes, it is in radians. It's going to be sine to the minus 1 and the minus 1 of a fraction 1/square root of 5. It says give our answer to 1 decimal place here. We can work with 2 decimal places until there are 3 significant figures until we're ready to give our answer. So I'm going to initially just write 0.464 radians. When I'm giving my final answer, I give it to 1 decimal place. So my angle theta is in those 2 quadrants. Remember though that this quadrant, angles in this quadrant, that we also want here. This quadrant, angles in that quadrant is pi minus alpha. Angles in this quadrant, pi minus alpha. So our angle theta that we want finally is going to be the first quadrant angle. The stick is the same value there. Right? Same value there. Smaller. It is 0.464 radians. And also this value here is pi minus 0.464 radians. But the question wants us to give the answer to 1 decimal place. So I'm going to put this as 0.5 radians to 1 decimal place. I'm going to work this out and then give it to 1 decimal place as well. So I'm going to do pi pi minus 0.464, and to one decimal place, that is 2.7, and 2.7 radians to one decimal place. Those are the answers for that one. Nice and easy. Nice and easy. Nice and easy. All right, next part is proof. That proof. So you look at this proof, you see that both of those come from the cos squared x. Why? Because cos squared x, remember, is 1 minus sine squared x. And 1 minus sine squared x can be written as the difference of two squares. 1 minus sine x and 1 plus sine x. All right, let me take this, shift this over a bit. Let's make it showing the groundwork, thought process behind this. So once I see these two things, I know that this should come into play at some point. But furthermore, let me make this a little bit smaller and shift it up here. If you observe what we have two fractions on the left side, two terms on the left side, and they have been consolidated into one. So your first order of business is to make this into one fraction. To make them into one fraction, you want the two denominators to be the same. So I'm going to multiply this fraction with the denominator of this one up here and down here. I'm going to take this denominator and multiply it up here and down here, and the two denominators will become the same. So ready, let's go. So left hand side becomes, multiply this one initially, let's write it first, 1 over 1 minus sine theta, sine x. I'm going to multiply the numerator and the denominator by this denominator. So it's 1 plus sine x, and I'm multiplying here by 1 plus sine x. That's what I'm doing with this first fraction. Multiply the numerator and the denominator by 1 plus sine x. And then the second one, that's this one. Let's write it back. 1 over 1 plus sine x. I'm going to take this one and I'm going to multiply the numerator by 1 minus sine x, and the denominator also by 1 minus sine x. So I've taken this denominator and multiplied this one, numerator and denominator. And I've taken this denominator and multiplied here and there. All right, and this then becomes equal to, the denominator becomes the same for both, and it's a difference of two squares. So the denominator for both is the same, so it's difference of 2 squared, which is 1 minus sine squared x. But that's the difference of 2 squared, which is this. This is 1 squared minus sine squared x. We don't need to put the square on the 1. Then we're going to add the numerators now. So this numerator becomes 1 plus sine x. Oh, we could just add up the whole numerator now. Okay, all right, let's write it out. 1 plus sine x, that's this one, and then 1 minus sine x, because 1 minus sine x times 1 gives us 1 minus sine x. So I'm adding 1 minus sine x over that. And what we see is that this sine x and this minus sine x are wiped out, and this is 1 plus 1 is 2. So it becomes that's correct. Oh, this was a minus, guys. Yes, I made a mistake. This is a minus. I'm supposed to be subtracting. So I'm going to be subtracting these. Subtract this. So I'm subtracting 1 minus sine x. All right, ready again. So this becomes equal to the 1 minus the 1. The 1 is gone. And then the sine x minus the negative becomes a sine x plus sine x, which is 2 sine x. I have what 2 sine x on the numerator, 2 sine x, dividing that with this 1 minus sine squared. But 1 minus sine squared is cos squared x. And I look at the answer here and I see that what tan. Where did that tan come from? Because this cos squared can be split up and written as 2 sine x over this cos squared. I can write it as cos x times cos x. And then this sine over cos right here is tan. So we get 2 tan x over this cos x. And that is the right hand side. All right, so essentially what we'll do is add the 2 fractions and it becomes that. And then we'll use a couple of the identities. So the fraction here is tan x in red right here. This is tan x. And it goes here. All right, that finishes that question. Which one again? Which one? Anybody else? Anybody else? You guys done? All right, so the call has gone silent. Let me check if I'm still on or disconnected. No, I'm still seeing people there. Giovanni, what up? You done?
Sir, I'm good, sir. I'm good, sir. Sir, somebody said they're still looking.
Huh?
Somebody said they're still looking.
They're looking for what? Questions for me to do? All right.
Yeah, it seems so.
All right, I'll go for another 45 minutes because you guys need to go and sleep. What time is the exam tomorrow?
9 o'clock, sir.
9 o'clock, sir.
All right, so I'll go on for another 45 minutes. So I'll give you a chance to look, see if there's anything else you want. I'll do it for you. So let me know if you are good. Very good. I'm gonna see if I can get this paper and work it out tomorrow. So you can check it. I worked out the pure maths paper today. So it's on my channel. I have 2 more questions on it to do. So I was working it out and then I stopped. So I could have this session. I think I'm just gonna finish it before I leave here. 2 more questions.
There you can do.
One, which one?
2019, question 6, part B.
2019. Question 6. That's like what? That's like the last question. No, 2019. They were still setting the old format, right? Yeah. 6B. I mean, this one.
Yes, sir. Yes, sir.
Alrighty. Remember, your level you want to be integrating x to some power n, right? That's what I want to be integrating. So you need to take this complicated looking thing and turn it into x to the n and see what n is. So, ready. So first thing, this 2 is a multiplying constant that can come to the front. So this can be written as 2 times the integral from 1 to 4 No, this x to the half, this expression is x to the half over this x is x to the 1 dx. When you divide indices, you subtract the powers. So this then is the same as 2 times the integral from 1 to 4 of x to the minus half, because half minus 1 is minus half. So the power becomes minus half. Good so far? Good so far?
Yes, sir.
Yes.
Put this up here. All right, so we are now here to integrate this thing. Oh, put back the dx, please. We're going to add 1 to the power and divide by a new power. So it becomes 2. Add 1 to the power, I'm going to get x to the half. Divide by the new power, which is a half between 4 and 1. Now this x to the half is just root. That's just square root. I want to take this, my half, and divide it under here. To divide by a half is to multiply by 2. So if I multiply this 2 by this 2, this half, divide this 2 by this half, I'm going to get 4 outside here. So it becomes 4 root x in here between 4 and 1. So reduce this to 4 into root of 4 inside here. We'll drop 4 inside here, get root of 4, which is 2. Minus, when you put the 1 in there, you get the root of 1 is 1. So the final answer is just 4, because this is 1. Okay. Good to go?
Yes, sir.
All right, which one again? Keep looking. Don't go in the exam. Any question? Any question to repeat, you should be able to do it. Any question to repeat, you should be able to do it. All right. So look again and see if there are any other questions you want me to do.
Sir, 2016, number 6.
2016,
Number
6.
6, A and B.
All right, hold on. All right, 2016, number 6. 2016, number 6. I don't think we opened 2016 from evening. Let me get it from over here. 2016. Mm-mm. 2016, I got a good feeling. 2016, number 6. 2016, number 6. All right. There we go. There we go. Go. All right. So this is just to integrate that. So we can just put some equal on this, right? So when you integrate cos, you get sine. Because when you differentiate sine, you get cos. So this part is just going to be 3 sine theta. When you integrate minus sine, you get cos. Because when you differentiate cos, you get minus sine. So I'm going to get about minus 5 cos theta. There are no limits there, so I have to put a plus c. I think I did a question earlier. No, I lied. There were limits on that one. That is it. And if you're not sure, let's differentiate this again. If I differentiate this, I'm going to get back this. Good. If I differentiate this, no, I make a mistake. I'm going to get a plus. Right?
So wouldn't that be
I decided. Yeah, good thing I decided to check it. See? Important of checking it. Yes. If I differentiate this, I'm going to get back that. So sometimes it's good to check so you integrate. All right, good. Next one. To integrate this one. Now, firstly, I'm going to put this as a minus 2 power. So I'm going to first write this as an integral from 1 to 3 of 2x to the negative 2 minus 3 plus 2x cubed dx. All right, this is going to become equal to, add 1 to the power and divide by the new power. So we're going to get 2x to the minus 1 over minus 1. That's for this one. For this one, we're just going to get minus 3x. And then this one, we'll add 1 to the power, it's going to become 4 over 4. So the 2 over 4 is going to give us a half. So we're going to eventually get plus x to the 4th power over 2. All right, and we're going between 3 and 1. Now this minus power means 1 over. Must be so I'm going to write down the real one there. So I'm going to simplify this first. I write it as negative, because minus makes this whole term negative. Negative 2 over x minus 3x plus x to the 4th power over 4. Still between 3 and 1. Let's plug in the values now. Equals. Plug in the 3 first. Minus 2 over 3. Minus 2 over 3. Put a 3 here, we're going to get 9. 3 is 9. Minus 9. Put a 3 here, we're going to get 3 to the 4th power. That's 81, you know. 3 to the 4th power is 9 times 9 is 81. So we're going to get plus 81 over 4 in the first bracket. Minus, going to plug in the 1 now. Instead of the second bracket. 1 inside here, so it's going to give me a negative 2. 1 inside here will leave me with a negative 3. 1 up here is going to leave me with a quarter. I can just put everything there in my calculator and get my final answer. Why not? Just set it out in the calculator as it appears there. Quick and fast and go about the business. And go to the next question, please. So it's a bracket. A bracket minus 2 thirds minus 9 plus 81 on 4. Close that bracket. Subtract. Open bracket. So this is minus 5. So I can put minus 5 for those. Minus 5 plus a quarter. 1 and 4. Close bracket. 15.3. Let's see what that is as a fraction. 46 over 3. 46 over 3 is the answer. If I write this 15 and a third. That's fine. All right. You want the whole of it? You want part B as well? Say yes.
Yes, sir.
All right, good. Next part now says, the following figure shows the finite region are bounded by these two lines. X equals 1, x equals 2. So then x equals 1, x equals 2. All right. And this is the curve right here. That is the curve. It says calculate the area of the region R. So the integral area is the integral of y dx. And we're going between the limits of 1 and 2. This is the y. I feel like you can expand that out as a separate term, but you can do it as a composite as well. All right, let's look. So when we do that, let me just do some of the work here. I don't like to be writing in these lines, right? Let's do some other work right here beside it, right here. Shift this up and do some other work right here. Zoom up. All right, so it's gonna become equal to the integral from 1 to 2 of this whole expression is y, which is x minus 1 squared plus 5 dx on everything, which then becomes equal to, integrating this one first, it becomes, integrate the whole, x minus 1 cubed, add 1 to this power, divide by the new power, and also divide by the differential of what's in there. While differentiating here, I can get 1. We still need to practice to show it. And then plus integrate this 5, I'm going to get 5x. I'm working between the limits of 2 and 1. Plug in the 2 first. A equals, plug in the 2 in the first bracket. 2 into here gives me 1 cubed. 1 cubed is 1. This is 3. Plus, plug in the 2 here. 5 2s is 10. The first bracket minus. Second bracket, plug in the 1 here. I get 1 minus 1 is 0. Plug in the 1 here. I get 5. And that's what I'm working on for my area. Equals. This becomes 10 minus 5. That's 5. Plus this third. 5 and 1/3 units squared. That is the area. 5 and 1/3. Ready? What next? Thing is, this one says the point P lies on the curve with this gradient function. Similar question. Find the equation. So I'm going to integrate. Means that dy, I'm going to take this dx and multiply it over here, is equal to 3x squared minus 6x times dx. All right, and so I'm going to integrate both sides. Some people just write y equal the integral of this straight, right? And so on, but no problem. So I'm going to integrate this side and also integrate that side. I'm going to give me these points. Those are for me to find my c. You can do it without finding the c. What you can do is recognize that this value is the x value and this is the y value. And I can put those values on the lower limit of your integral. On this side, we're integrating the y, so I put the y value over there, the 2. All right, so I'm going to put the 2 down here and put the corresponding value, which is the x value, and the base on the one that's integrating with respect to x, which is 1. Integrating up to a value of y as a general point. Integrating up to a value on this side of x as a general point. So this is a way to do it without having to calculate the c first. All right, you don't have to put in a c. So already know, when you integrate this side, it's like you're integrating a 1, like there's a 1 there. So it becomes y. Integral of 1 with respect to y is y. And you're going between y and 2 equals integrating this now. When you integrate this one first, you're going to get x cubed. 1 because you add 1 to this power, you get a 3 and divide by the same 3. Cancels with this one. It says x cubed. And then this one, we integrate this one, you square this and divide by the 2. So you're going to get 3x squared. So you're going to get minus 3x squared. And integrating between the limits of x and 1. So these now is what you would normally use to find your c in the function. So here now, you plug in the y first, you're going to get y minus plug in the 2, you get 2 equals. Here you're going to substitute the x in here first. It's going to come back as this. It's going to become x cubed minus 3x squared. Then you subtract. I'm going to plug in the 1 now. 1 into this gives me 1. Minus 1 into this makes this 3. So these calculations will calculate your c for you. within the workings of the question. So the final thing, I'm going to take this -2 and bring it over there. I'm going to get y equals x cubed minus 3x squared. This is going to become a minus -2, which is a +2. And then this 4 is going to go and add to that 2. This 2, I mean, going to go and add to that 2. I'm going to get 4. So I'm going to get that 4 over there plus 4. So if you work it the original way, your C will be equal to 4. That is it. That is it for this one. Another question?
Yes, sir. Question, same paper, question 2, part B.
Question 2. Question 2. Oh, here. Oh, this one?
Yes, sir.
All right. It's a series, summation, series question. All right, the first thing I would say, don't work with negative powers. Don't work with negative powers. So I'm going to write this initially as the sum from 1 to 25 of this becomes 1 over 3 to the n. That's what it is. This 3 to the minus n means 1 over 3 to the n. Then I'm going to see what kind of series it is. Because your topic for your series is really AP and GP. It's going to be a GP. Once you have that power thing, it's GP. So you start with the first few values and see. So plug in the 1 first, you get a third. You're adding them because that's a symbol for summation. You're adding the values. The next one is 1 over 3 squared. 3 squared. The next one is 1 over 3 cubed. And do that all the way down until we reach 1 over 3 to the 25. So realize that this is the GP because you keep multiplying by a third from term to term. So this is a GP. We have a GP. We have a geometric progression, geometric series. The first term is a third right here. And the common ratio is also a third. And the number of terms is 25 because you sum from 1 to 25. So the number of terms is 25. So you're trying to find the sum of a GP where this is the first term, this is the common ratio, and that is the number of terms. So I'm going to use a formula for that. So the formula, I'm going to write it up here. Sum to n terms of a GP is A into 1 minus R to the n over 1 minus R. It's on the formula sheet. Just as on the formula sheet, sometimes we write R to the n minus 1, R to the n minus 1 over R minus 1 inside here. But it don't matter. All right, work out itself. So I'll plug those values into that formula and get the answer. All right, let me use the reading because the reading shows better here against the black. So my SN, my S to 25 terms, S to 25 terms is going to be, the A up here is a third bracket, 1 minus a third, 1 minus a third raised to the power of 25. Let's write that better. Raised to the power of 25 inside that bracket. And dividing all of that by 1 minus R, which is another third. And then I can just put all of that in my calculator and write my answer. No need to complicate it. Just put it in the calculator. The calculator can take it, put it in there. So it's going to be a fraction, and a fraction on there, starting with a third. I'm going to put an open bracket, 1 minus a bracket, another fraction, a third, close bracket, raise that to the power of 25, come out of there, close my bracket, and the denominator is 1 minus a fraction, which is a third. So I type it in there exactly as it is. That looks like 0.5. That is 0.5. So this is 0.5. Look at that. Not necessarily, no. I don't have to be 0.5. Let's get to that fraction. Let's see if we get to that fraction. Let's see. 0.5. 0.4999 almost. 0.5. 0.5. That is that. Down here now. It says, let's continue it because the red shows better against this these lines. It says a man invested X dollars in a company in January 2010, on which he earns quarterly dividends. Remember, there are 4 quarters in a year. All right, 4 quarters in a year. It says at the end of the second, third, and fourth quarter in 2011. So what is happening here is that, let me make this a small and do some work. Right. What is happening here is that when you get to the second, third, and fourth quarter in 2011, he would have already completed 4 quarters here. All right. All right, so it's gone to 4 terms here, I should say. And the second, third, and fourth would therefore be your 6th term, your 7th term, and your 8th term in the series. All right. And those values were 100, 111, 15, 130. So clearly, it's an AP with a common difference of 15. We don't know the A. But what we know is that the D is an AP, right? That's the first thing. It's an AP. It's an arithmetic progression. And the D is equal to 15. We're going to just put 15. We're not working in dollars. But then now, this 100 is our 6th term. And the 6th term is A plus 5D. Remember, term is A plus N minus 1D now. And it is equal to 100. I can take this 15 for the D and drop it on this. So I'm getting A plus 5 times 15. Let's write this better. A plus 5 times the 15 equals 100. Now this 5 times 15 is what? 75. 5 times 15 is 75. That's correct. 15 times 5, 40, yes, 75. Good. So if I subtract the 75 over here, I'm going to get the A equals 25. So I have my A and I have my D. And it says AP. Question says, let me take these markings off now. The question says, calculate the total dividend at the end of 2016. So we need to know how many quarters are there. You have to be careful when you're doing these serious questions with time. A lot of persons would maybe go and say, okay, 6 years, and go on 2016 minus 2010 and say 6 years. But no, it's not actually 7 years, because you have to include the period in 2010. You cannot subtract, right? Because if you were to list out the number of quarters total, to be 2010, 2011, 2012, 2013, 2014, 2015, and 2016. 1, 2, 3, 4, 5, 6, 7 years. 7 years. All right. Each year you had 4 terms. 4 quarters. So the number of quarters of the 2016 is 4 times 7. So you're summing, taking the sum to 28 terms. So you can say the number of terms in which here, the number of, let's say number of terms becomes 7 years times 4, which is 28 terms. There are 28 quarters that you're summing to. So you're actually calculating the sum to 28 terms for this question. So the sum, let's based on here, let's do it on here. The sum, 28 terms, remember, it's 28 over 2 into 2a plus n minus 1. This becomes 27 times d. That's what we're working out. So it becomes 28 over 2 into 2a. What is the a? A is 25. We're working in dollars, and don't forget working in dollars. 25 plus 27 times the d is 15. Working in dollars. So we'll get the answer here, we'll just put dollar sign in front, right? That's the total dependence collected. So we're gonna put this in the calculator. And we're gonna get, well, outside here is just 14, right? 28 over 2 is 14 times, well, this is just 50 plus 27 times 15. So you get $6,370. $6,370. Let me tell you something. I'm going to show you something before I seem to on this thing with time. If you get a APGP with time, right? And counting years. So usually A is when you start, and the start is the year 0. If you're doing a question with time, right? When you start with the first term, you're at the year 0. When you start, the number of years is 0. So when you make your first, when the series start at for the A, you're at year 0. That's your first term. That's when the n equals 1, you know. So this the first term, A, is when the n equals 1. The second term, which is A plus D, your n is now equal to 2. If it's something where it's annually, then you're just 1 year after. So your year number is now 1. Then the next term is when n equals 3. That is A plus 2D. But the year, number of years that has passed since you started is now just 2. So you realize that your year number will always track 1 behind your term number, because your first term corresponds to when you start, the year is 0. So a good relationship to remember, right? You can know it from here, you know, because your first term is 1, your year is 0. Your year, number of years, will always be n minus 1. N minus 1. So just like here, when the number of years is 2, the term number is 3. Right? So if you're doing a question that asks you something with time relative to the number of terms in the series, just remember this. The number of years is this, n minus 1. Just be mindful of that. So you calculate n. If you want the year, you have to subtract 1 from it. If they ask for the number of years, something will happen, they need to find the n term and subtract 1 to find that number. Just remember this relationship. I can't say exactly how the question will appear for you to use it, but you will know that the number of years since the series started is tracking 1 behind the term number, simply because when you start, n is equal to 1, but the number of years is 0. I don't pass a time yet at the beginning. All right, so remember that for the year's question. Any other question? What time is that? So you guys have to go and sleep, you know. You guys have to go and sleep. What time is it now?
Yes, sir, me I gotta sleep.
Well, all right then, guys. Good luck tomorrow. Remember, I could check something before you go. I could check something before you go. Because you can't just run in there. I could check something before you go. Set some ground rules before you go. All right. Advanced 2023. So the paper is going to be basically of the same structure with respect to the number of questions that I'm talking about. The number of questions. Now, each question carries 20 marks, right? Each question is for 20 marks. Let's make sure of that. So we're basically saying the weight on each question is the same. Let's look at it. The weight on each question is the same. I'm discussing the time, the time management. You have to manage the time in the exam room. You cannot just be working blind. Oh, this one is 15 marks. All right, let's see. 15 marks there. I think all the questions in this first section, 15 marks in that model there as well. Come down here. Let's see here now. Next question. Where is it? Where is it? 20 marks. Okay. So the first two questions is 15 each, right? Trying to work out a kind of a plan. 15, 15, 20. All right. I'm sure we divide the screen. Divide the screen. And write it down. 15, 15, 20. You have to be kind of strategic in the exam room, guys. You have to be. You cannot just work in blind. You have to manage the time. All right. So 15, 15, 15, 15, 15, 20 so far, right? Number 3, 20. Then we come to number 4. Much marks for number 4? Number 4 is 15 again. And then another 15. Don't know what is about number 3, where it was 20. And then 1, 2, 3, 4, 5. This is 20 again. 20. All right. That's the marks. Now, what is that up to? This is 30, 30, and this 2 make 100. So total marks on the paper is 100, right? What is the time for the paper? Total time for the paper is, where is it? Total time for the paper is 2 or 40 minutes. 2 or 40 minutes is 120 plus 40, which is 160 minutes, right? So essentially, I got a cool calculation quickly. This is 100 total, and the total time is how much? 160. All right. So the time that you're given each one is 15 over 100, 15 over 100, 15 over 20 over 100, over 100, over 100, over 100 times 160. All right. So how the calculation works. And I'm going to see the time saving time, right? So I'm going to say how much time must give the 15 minutes question, the 15 marks question, how much time must give the 20 minutes marks question, right? So it's 15 over 100 times the total time of 160 minutes. So basically the 15 minutes questions must get 24 minutes each. And the 20 minutes questions, 20 minutes questions must get, this is saying 32 minutes each. So it's big, right? 32. So what you're going to do now? You're going to give the 15 minutes questions 20 minutes and give the two big questions. You're going to give them 30 minutes. Don't pass 30 minutes on them. So if you say a 50 marks question, 20 minutes on it. Don't spend more than 20 minutes on it. And if you say a 20 marks question, Don't spend more than 30 minutes on it. 30 minutes. And what that will do, that will allow you, in fact, you should have spent 25 minutes on the 20 minutes question, but that will allow you, because you're going to have time to come back. You're going to have 1, 2, 3, 4. Time to come back and check. You're going to have 4 times 4 minutes plus 2 times 2 minutes. That's 16 and 4. You're going to have 20 minutes to check over when you're done. If you do run the plan there. So see the rule there, guys. 20 minutes and the 15 minutes, 20 minutes and the 15 marks questions. 30 minutes and the 20 marks questions, please. That means if you're working on a 15 marks question and 20 minutes pass, you move on. Remember also that each question, so part A is a question by itself. Part B is a different question. Remember that as well. So it means in question 1, for example, you might encounter 3, 4 different questions in question 1 alone. See there? Right? Different questions. See? This is a different question, unrelated to the others. So this is 3 questions. So remember then that if you read this part of a question, and you can't do it, and don't want to do, no problem, leave it. Right? Do the questions in each, do the parts of question that you know how to do. If you get a proof to do, right? You have to use the proof, what you prove in the subsequent parts of the question, but you can't work out the proof, no problem. Go and use the proof that they have directly given. Suppose for the example, they give you some information, and they say, show that v equals 3x squared minus 5x plus 6. And you can't work out this proof. But them say, hence, find the maximum value of v, or what, something like that. You can't do the proof, you know. We can use the result of the proof down here. So you go on down here and use the result of the proof, even if you can't complete the proof. Use the result of the proof. All right? And that is the case. But don't come out the exam room and say you never reach question 6. Right? If you manage the time this way, as I'm showing you over here, if you manage the time as I'm showing you over there, give each question a specific amount of time, then you will do work on every question and you will get a chance to do the parts of every question that you know how to do. Get me? Why is this question 20 marks? I guess because the entire question relates to one thing, you know, number 6. The entire question relates to one thing. In fact, it's 2 parts. This part of it was the information there. And then down here now, same question. And then this now, same question. So the entire question was about the same thing. And so, yes, the entire question was about the same one thing. And I give it 20 marks. Let me look at number 3 on this paper and see why it was 20 marks. Just to see. It's a tricks question. It's the first question in this. And it's too much. One question that had 2 parts on it. And then they have the vectors, part B, and they have the tricks. Maybe that's why I characterize 3 solid topics, and they have the proof down here. So you have a number of parts on it. But then they still have different questions, because this question down here is different from this. This is by itself. And then this question is one question. So this question alone have 3 different things. 3 different questions on it. A is one question, B is a question, C is a question. It's 4 actually. And these are different questions. All right. So maybe that's why I carry so much marks. But guys, do not make it be that I may ask you tomorrow if you attempted all the questions. Just say no. You have to attempt all the questions, and the way to do that is to manage the time. Give each question a set amount of time. If you follow this plan, 20 minutes for the 50 marks question. If you want to get one next 2 minutes, 22 minutes or so. But don't make 24 minutes pass. And for the 20 minutes question, don't make 32 minutes pass. Try for 20 minutes and 30 minutes, and that will give you a solid 20 minutes at the end to go back to the parts that you skipped out. Do not waste time on questions we don't know how to do right away. Do all of the questions we know how to do right away first. And then you come back now on the questions we have to think through and so on, and do those afterwards. All right, there are the questions that you will know how to do right away, they're right across the paper. So if you come up in this first part of the exam and you book on a question we don't know for the right away, leave it for the time being. Go through the paper doing all the questions that you know how to do first, and then you can come back if you see a trouble question on the paper. All right, guys, so good luck tomorrow and do your best and stay calm. You're already prepared to do a lot of work. All right, and remember, if a question is difficult for you, it's more difficult for everybody else, so don't bother worry about it. Just keep working. All right, don't worry about it. All right, guys, bye. See you all tomorrow.
All right,
Have a
see.
good night, sir.
All right, yeah,
All
man,
right,
cool.
sir.
Bye-bye, bye-bye. I must do this. All right, guys, on the chat, I'm going to end it now. Wish you all good luck in the exam tomorrow. People on the live, on the Zoom, on the YouTube. All right, hope the sessions were helpful. You can go for the solution for the paper on this channel. All right, hopefully I'll get it and be with it tomorrow. Good luck, everybody. Have a good one. All right.